IITM has completed 60 years of fabulous service to the nation in weather and climate science, and therefore our celebrations are longer than usual. On 15th November, we celebrated the hard work and success of many of our colleagues, listened to some very interesting talks on different research being carried out in IITM from the Professor P.R. Pisharati and Professor T.R. Sikka awardees, and sang and danced our hearts out at the cultural event. In continuation with this celebration, today we will be having our scientific session for which we have amongst us many special dignitaries who have specially come to join us to celebrate our Diamond Jubilee year.
Yeah, we are truly honored to have among us our distinguished chief guest, guests of honor, former secretary, former directors, esteemed scientists of IITM, past and present and past. We also have among us dignitaries from MOEs and sister institutions. We are delighted to welcome you all for this Diamond Jubilee celebrations. Your presence on this occasion is an honor to us and is recognition of the significant and impactful journey of the Institute during the last 60 years. I now request the dignitaries to come onto the dais, please. Today's chief guest, Dr. Ravichandran, Secretary, Ministry of Earth Sciences. So please come on to the dais. I may now request our guest of honor, Professor Jagdish Shukla, George Mason University, USA. I now request.
Thank you.
I now request a guest of honor, Professor R.N. Keshavamurthy, former director of IITM. I now request Director Dr. Krishnan. Thank you, sir. I now request our director to give the welcome address.
Respected dignitaries on this stage, today's chief guest, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences. Guests of honor, Professor R.N. Keshavamurthy, former Director of IITM, Professor Jagdish Shukla, Managing Director, COLA, Professor Climate Dynamics, George Mason University. Respected dignitaries of this stage, the galaxy of distinguished delegates and participants, former directors of IITM, former secretaries of MOES, DOD, and various ministries, directors of MOES sister institutes, and other research and academic institutes, present and past members of the IITM family, well-wishers and colleagues. Namaskar, good morning to all of you. I extend a very warm welcome to all of you on this important occasion of the 60th anniversary, that is the Diamond Jubilee celebration of IITM. And this also coincides with the Azadi Ka Amrit Mahotsav celebrations launched by the Government of India after the 75 years of independence. And this is a great juncture to celebrate the evolution of the institute that has emerged as a world-class center of excellence in tropical meteorology, monsoons, weather and climate prediction, and various aspects of the atmosphere and oceanic sciences. We are very fortunate to have with us today Dr. M. Ravichandran, Secretary of MOES, as the chief guest, and Professor R.N. Keshavamurthy and Professor Jagdish Shukla as the guests of honor. Very interestingly, all the three dignitaries on the stage have worked in IITM for many years and are still continuing to provide the valuable support and guidance to MO and guidance to IITM. Thus, thank you very much for kindly accepting our invitation to grace this important occasion. The evolution of any institute is shaped by the visionary leadership at higher levels, and also very importantly, the contributions made by the past and present staff and employees. On this historical moment of the IITM Diamond Jubilee event, I wholeheartedly thank the entire IITM family, the past and the present employees of the institute, all the past directors, and our parent ministries and well-wishers for their contributions, constant support, and guidance to IITM. We have planned today's program by starting with the scientific session in the morning until lunch, and the IITM Foundation Day function is scheduled in the afternoon. An important feature of the scientific session is the brainstorming discussion on improving monsoon forecasts in a changing climate. While significant progress has been made in weather and climate sciences during this last several decades, we are also faced with frequent challenges to improve monsoon predictions in a rapidly changing climate. As the Earth's climate continues to warm, extreme weather and climate events like heat waves, tropical cyclones, heavy precipitation, floods, droughts, etc., are projected to increase both in severity and frequency, at least for many types of extremes. Also, the monsoon hydrological cycle has become more variable with increased vagaries of the monsoon weather, which are becoming unpredictable, and we experience frequent occurrence of intense precipitation events across various monsoon regions. The aim of this brainstorming session is to develop a scientific roadmap and strategic plan for the next 10 years in which IITM would take a leadership role for improving the understanding and prediction of monsoon across scales in the backdrop of global climate change. Without taking much time, I once again thank you all and welcome you all to this scientific session of the IITM Diamond Jubilee Foundation Day event. We have received the information that the Honorable Minister of Earth Sciences, Dr. Jitendra Singh, is unable to attend the IITM Foundation Day function in the evening due to some urgent engagement. Therefore, we have suitably modified the agenda for the afternoon session, which now starts from 3 p.m. The morning scientific session remains same as before. This inconvenience is regretted. Thank you all once again. Jai Hind.
Thank you, sir. I now request Dr. Ravichandran, Secretary, Ministry of Earth Sciences, to declare the opening of the scientific session.
Professor Shukla, Professor R.N. Kesavamurthy, Dr. Krishnan, past secretaries of MOES, DOD, Professor Gao, Dr. Rajivan, and past directors of IITM, I could see Professor Ravi Nandandia and others, and all other invitees and my colleagues from IITM, MOES, and other institutions. Very good morning to all of you. It is indeed my great pleasure to be here as part of this Golden Jubilee, Diamond Jubilee celebration of IITM. Being started my career from IITM, it is my doubly. I'm happy that I'm at this 60th year. I'm here, 60th anniversary of IITM. I'm here, and it is a double pleasure for me. Of course, I don't want to talk about what is that achieved by IITM, what need to be done by IITM in future. That I am maybe brief about in the afternoon. At this point of time, I congratulate all IITM employees, past, present, maybe in the coming years, maybe the research scholars and other people. And I will not take much time. I once again thank you, Dr. Krishnan, for inviting me, and I declare the scientific session open now. Thank you.
It gives me immense pleasure to introduce our today's guest of honor, who is a well-recognized figure in the field of meteorology and our former director, Professor R. Keshavamurthy. Professor Keshavamurthy worked with the great institutions like India Meteorological Department, Physical Research Laboratory of Ahmedabad, IITM, and also JFTL Princeton University, USA. Professor Keshavamurthy has done extensive and pioneering work on various aspects of monsoon variability, instability of monsoon flows, and relation between ENSO and monsoon. He, jointly with F.R. Miller, discovered a new synoptic scale system of the monsoon circulation. Since then, it is well known as mid-tropospheric cyclone, MTC. He contributed significantly to several theoretical and modeling aspects of monsoon. Professor Keshavamurthy applied the JFTL atmospheric general circulation model to understand the role of SST variability in modulating atmospheric circulation and the monsoon in particular. His AGCM numerical simulation experiments were among the first in this field to bring out the influence of SST anomalies in the eastern and central equatorial Pacific Ocean on the interannual variability of the monsoon. During his tenure as a director at IITM, he established a new division of climate modeling in 1993 and effectively guided in its years of infancy. Immensely contributed to the science of meteorology and authored several research papers and books on the phenomenology of monsoon. He guided several students for their PhD degrees, including Dr. R. Krishnan. In recognition of his various scientific contributions, he was conferred the Hari Om Ashram Prerit Vikram Sarabhai Award, B.N. Desai Award of the Indian Meteorological Society, and the IITM Silver Jubilee Award. He is a fellow of the National Academy of Science and the Indian Meteorological Society. He is a member of various national and international committees, including the WMO Joint Scientific Committee of the World Climate Research Program, WCRP. In recognition of outstanding contributions to the atmospheric science and technology, the Ministry of Earth Sciences honored him with a National Award in Atmospheric Science and Technology for the year 2011. Also, in recognition of his outstanding and pioneering contributions in the field of meteorology, the Indian Meteorological Society honored him with the Sir Gilbert Walker Gold Medal. Thank you, sir. Thank you, sir, for accepting our invitation and becoming the guest of honor of today's event. It is indeed a great honor to have you among us. On behalf of IITM, I request you to kindly say a few words on this auspicious occasion. Please, sir.
Thank you for your very kind words. Let me at the outset say how happy I am we are participating in this 60th Diamond Jubilee celebration by IITM as part of Azadi Ka Amrit Mahotsav. Really, it's like a homecoming for me because I lived here for several years. I began my early scientific career, research career here in IITM. I still recall those days. Dr. Ramakrishnan was the director. He was like a father figure for us. I was in that Asnani's group. Asnani was like an elder brother. It was a great time, fun time. We did some good work, I think, in those days. Of course, we had less facilities than now, but the first founder director was, as you all know, Professor Pisharati. This land on which you sit here today was acquired by Professor Pisharati. He made several trips to Bombay, Maharashtra government, used to call Mantralaya. So he made several trips and got this land. So he used to tell me story. I was very closely, I worked with him in PR, Physical Research Laboratory. So he used to tell me stories. I think I leave the great science part to my colleague Shukla. I will tell some stories. So he can big science. So he used to tell me that he got this land. He asked, they estimated some amount of land for this institute, and he asked for twice the amount of land. So I used to ask him, why did you ask for twice the amount? Is it not a waste? He said, see, he said, nursery rhyme, Baba, black sheep, have you any wood? Yes, sir, 3 bags full. One for me, and one for master. Master was the IMD. he knew that IMD will grab half of it. He grabbed the other side of the road, the other side of the Homi Baba road. That part the IMD grabbed and they didn't waste it. They built training, wonderful training institute where I was trained. I think it was a wonderful training institute. At that time, when I graduated, I came from college. There were 2 training institutes. One was the BRC, Homi Baba training, which was excellent. And the other was IMD training, which was excellent, which was not known. Because in those days, I started as a PhD student in IISc Bangalore, but I needed a job. So I left that and came, and then people said, why are you foolish? You are going to meteorology. I think I have done it was a great thing for me, luck, fortune for me that I came to this field, this wonderful, this field. Then I went to, after the land was acquired, there came several directors, I think Ramanamurthy and Sikka, they got these buildings built. When we were there, I was working in the initial stage as a research scientist. We worked in the Ramdur House, the highest building behind IMD. And some other small building. So then, with the effort of these 2 directors, I think we got this beautiful campus built and they moved here. I came here, then I moved to PRL from. I was in IITM, then IMD, then PRL. We formed a small group to work on theoretical aspects of meteorology, dynamic meteorology, etc. It was an active, very active group. But we soon found that in the environment of physics, these physics people always talk about, I'm also originally from physics background. They always talk of analytical. Why don't you do analytical? Why are these numerical results second class? They don't understand. They deal with very simpler systems. We are dealing with a complex, very, very complex system. Atmosphere, ocean, everything. It's a non-linear dynamical system. Most of them deal with, I think, linear systems, and so they are able to do things with analytically. But so we thought we have no growth here. So we asked for a bigger project from DST. Fisherite got it sanctioned in those days. And that project, of course, got curtailed with some other reasons. So with that small project, they came here as directed in 1992. It was a great fortune for me that I came here. And there were still some problems in IITM at that time. They had a tiny computer, and the library was very small, and of course the building infrastructure was very good. So I thought I gave up my research work and became a sort of full-time director. People thought I did a stupid thing by doing that, but still, we bought in those days with the project money that we had. We bought the best computer that US would permit us to buy in those days, and then I could hire a large number of excellent people here. They formed the future of IITM. One is Dr. Krishnan here, and we upgraded the library. We started a large student program. So we sort of started the modernizing and liberalizing of IITM at that time. Then later directors, Dr. Goswami, Ravi, and now Krishnan, they are taking it to newer heights. I think the great good thing that happened to IITM was that it moved to IITM. So is the funding enormously increased, and we have the wonderful computer facility, one of the best in India. And I think I would request you, sir, to apply and whenever it's possible. I think I would now I'll come to some comments on science. Of course, we with the short range prediction, with the numerical models steadily improving from after days, and with the availability of larger computers and increase in resolution, short range prediction has remarkably improved even in the tropics, even in India. Short range storm prediction remarkably improved. Maybe up to a couple of a little longer, but seasonal prediction is still problematic. So if we are dealing with a thermodynamic system where there are a large number of irreversible processes, maybe it's a partly open system. It's not a simple system. So I would, of course, now that is the challenge for the younger people here, but it's a wonderful field, and I think we should all enjoy the work in this field. I think that the active guidance of Dr. Krishnan, with the support of more years, we will become Atmanirbhar in this field. I would also like to say to the younger scientists that we scientists and we are sort of privileged people, so we should also think of giving something back to the society, because we have enjoyed all the education facilities of this country. We have some salaried jobs. We may not be rich, but we are okay. We are reasonably well off. So I think we should give something back to the society. In that sense, I think we should write books, go to colleges, teach them, and say we are not Bill Gates giving money to the back, but we can give knowledge. It's in our great Indian tradition. We always give knowledge to other people, poor colleges. You should go to colleges. Maybe you should adopt other colleges, lesser and try to help them. Thank you very much.
Thank you, sir. So this indeed took us to the golden days, old and golden days of IITM. And thank you, sir, for providing us a glimpse of history of IITM. So I would now request our dignitaries to kindly take their seats in the front row of the auditorium, please. We'll be preparing the stage for our Foundation Day lecture. No, sir. I'm giving you an introduction. So I'll give a brief introduction of our guest of honor, Dr. Jagdish Shukla. Professor Jagdish Shukla is a well-recognized figure in the field of weather and climate research. He is a distinguished university professor at the George Mason University, United States of America, and the managing director of the Center for Ocean, Land, Atmosphere Studies, COLA, in the USA. He was associated with IITM during 1965 to 1971. Professor Shukla has immensely contributed to the science of meteorology and study of climate dynamics that has led to the development of a scientific basis for the prediction of climate. His pioneering work helped lay foundation for dynamical seasonal prediction at the time when the community was quite skeptical about its prospects. He has authored over 250 scientific papers and has been an advisor of over 20 PhD students. Professor Shukla has also been an institution builder. He is well known for the establishment of the Institute of Global Environment and Society, IGES, and COLA in the US. He also helped to form a weather and climate research group at the International Center for Theoretical Physics, ICTP, Italy, which provides training to many scientists from developing countries. He helped establish the National Center for Medium Range Weather Forecasting, NCMRWF, in New Delhi, which was the result of a landmark agreement between then President Reagan from US and then Prime Minister Rajiv Gandhi. He has also established the Gandhi College in his native village for education of rural girls. Professor Shukla has won many prestigious awards such as Padma Shri, International Meteorological Organization Prize, Rossby Research Medal, Exceptional Scientific Achievement Medal from NASA, and many more. He is a fellow of the American Geophysical Union, Indian Meteorological Society, American Meteorological Society, to name just a few. Thank you, Professor Shukla, for accepting our invitation and becoming our guest of honor. I welcome you on behalf of IITM and request you to please deliver our Foundation Day lecture.
Who's monitoring the time? You will be monitoring the time. Please give me a 5-minute notice in case I don't go over. So can you please go over this? Yes. I can just click. I'm technologically challenged.
Yeah,
this is. I don't want to show a slide now. Okay. Can you have the lights for the time? On? Yes. The first 10 minutes. Light on. This is the only one that you got to, right?
So this is just.
And I do this. No.
And just display?
Well, I'll call it.
Yeah, no problem.
Just give me more.
Yes.
Okay. I can start. Honorable Secretary, MOS Secretary Dr. Chandran, Dr. Keshamurthy, Dr. Krishnan, and friends. It is my absolute distinct honor and privilege to participate in this Diamond Jubilee Anniversary celebration. And I really like to thank Dr. Krishnan and Dr. Chandran for giving me this opportunity. I have prepared 2 separate presentations according to the old schedule. One when there will be opening session in the praises of Honorable Minister, and then that was the real election. So that is combined now, I didn't have time to go back and change my talks. So I just replaced Honorable Minister to Honorable Ravichandran. Okay. And basically I have decided to just keep the first 5 minutes while the lights are on, what I would have said, okay, in the morning, in a way, and then I'll give the second part. That's why I told the young lady to give me a notice. I don't want to delay. And you see, IITM is where my life in meteorology started. Okay, somebody was just, people have come in different times here. Well, guess what? I worked here 58 years ago. I was 20 years old, and God's grace, whatever it is called, I got a junior scientific officer's job here. Okay. And in fact, I was looking for how many people I know who might be here. And then I finally found last night, P. Brahmanand Rao. He actually joined soon after me, just a few months later. on this. And I mean, there is, so, Keshav reminded me of Pisaroti. There's so many stories I could tell you, but that will take all the time. I also plan to say stories. I've got, there are two parts. But then I got these 3 envelopes just now. And I'm just so delighted that these 3 people, I had such a huge respect for them. Dr. Pisaroti, Dr. Krishna. And Pisaroti, you can just talk to him and you know, I mean, he will talk like a friend, he was a real scientist. Another Krishna, every time we'll go for the map discussion in IMD, we really engage him. He was sort of with the discussion. And Anna Mani, you will not probably believe how I knew her so well. Because the IMD guest house was in Ramdur House. Those of you who might remember. Where next to my office. And many days I'll be working late in the evening. And then I'll see this young, lady in a sari coming out right there. And she will ask, oh, you're working late. And then I started talking to her. So every time she will stay, so we really got to know her very well. Thank you very much for this. This is a great honor that you have honored them 3. They're just really amazing people. So, as I said, you know, if you look back at the establishment of IITM, it's really the dawn of a new era in weather and climate science for the country, not just for IITM. And in some way, I feel very privileged to be involved with it for the 58 of those years. Because this institute has not only excelled in research and modeling, prediction, predictability, climate diagnostics, observations, field experiments, taking observations to field experiments, and most of all, training a new generation of weather and climate scientists. And actually, it has contributed to the overall development of weather and climate enterprise. And it is quite remarkable that now, Dr. Krishna mentioned, some of the most advanced models are being used in India. And IITM has played a role in providing these models to the operational IMD. And these predictions are saving lives, saving property. This is a, I mean, you know, our field has one problem. We cannot sort of take credit for what did not happen. It's very hard to take credit for. The only way we'll have to just look at the same cyclone till 11,000 people before, and now 4 people. So, you know, if you can explain that, then the people will understand. So anyway, I will just make a few science comments now before going to my talk. That as a secretary or even as a minister, there will be a requirement of public's expectation of better and better forecast, higher and higher. Give me village level forecast, give me district level forecast, and so on. Look, I have been working on the field of predictability for most of my life. Ed Lorenz, who is the father of chaos and predictability, was one of my 2 advisors, well, one of the 4, Johnny was the other one. So I can stay with some understanding of the problem. I think we have to be just very honest to tell the public and tell people that, look, there are limits to predictability. And these limits are not imposed by how hard we are working and what we are doing. They are imposed by laws of physics. And therefore but doesn't mean we have reached those limits. That is our goal. We want to strive to reach those limits. Then if you come to IITM, if there's any organization in the country, and now it's comparable to the world, which can actually give a scientifically valid, real justification to show what are those limits, there's IITM. And it is working on it. I'm so happy to see it working on medium range, weekly forecast, seasonal, and climate change. And I'll talk a little bit more about that in the future. So I think that, the only thing I'll say about the future of climate modeling is that, and I mentioned to Dr. Krishna yesterday when we were talking, every modeling group in the world is, of course, struggling to get bigger computer, more funding, and improve, models are improving. However, we have also realized that just like the physicists, each physics center in the world had an accelerator, but none of them were so powerful that they could do what CERN does in Geneva. Okay, you needed 7 teravolts. The same thing in climate is going to happen. I think all the countries in the world are expected to collaborate while building their own modeling center to create some level of international sort of institution, which will really do things which are impossible to do now by anybody. Now you may ask, what is impossible to do now? I'll tell you. A 1 kilometer global model is impossible to do now by any institution. And if you are interested in regional climate change, if you are interested in, you can do a 1 kilometer global model of 5 days, maybe. But right now we are doing like 3 kilometers, the best anybody has done. So you see there are problems, and they're not just computer problems. They're scientific problems. We need to understand that. So just keep that in mind, because very soon, Dr. Ravichandran, Dr. Krishnan, I can give you advance information. You will be getting an invitation to come to a meeting in Berlin, where the world community is getting together. They call it the World Modeling Summit #2. Some of you must have heard about World Modeling Summit #1, which 2008, I think Tim Palmer and I had organized, and it really helped. So that's about to happen. So, all right. So I really think that I would like to end the introductory part of the lecture by simply congratulating both Secretary of State, MOS, Director of IITM, for nurturing and supporting this institute, which I consider to be a shining jewel in the crown of MOS. I think that more than anything else, I would like to congratulate the, of course, IITM director, but more than that, IITM staff, very hardworking. See the number of publications, see the amount of, and for making it possible for IITM to be the world-class research institute. So thank you again for inviting me. Congratulations. And I will end my talk with applauding for you, Director and the Secretary. All right. So let's just go to the second part. And before you start showing the slides, I just want you to know what I'm going to do. It's not a conventional talk. I asked many people, what should I talk about? Everybody said, Jovi, whatever you want to do, just do it. And I said, okay, so I chose the following. I'll just tell stories about when I came to IITM. But I'm going one step further, and I hope you'll bear with me, to tell you what I was before I came. Somebody was interviewing me for some stories, and the reaction, this person says, oh, the chaos in your personal life is much more than chaos in the climate system. And I could realize, and I'm not going to go into the details, but the only IITM example I can give you is that I came to join, and they asked me to sign a form. There was a form, married or not married. So I said, married. Wife's name? I said, I don't know. No, I'm not joking. That's why I was 17 years old, and my marriage was fixed. I got married, and I never saw her. But only when IITM sent me for training abroad, it was arranged. So my point is that the background to which I came here is something that is quite unusual. I would like to share with you, and then I'll go to IITM, what happened. Then from IITM to MIT, see, I get confused with the ITM. And by the way, first we used to call ITM, do you know that, in the beginning? Then it became IITM. So that's what I'll do. But then in between, I'm going to talk about scientific ideas and how the research ideas develop. And that will be the message for the younger people. And the message will be very simple. You know, if you have an idea, just don't hesitate. Just come out and say it. And if you're not a good idea, and I'll give you examples. What happened to me, and just imagine, I was interested in long-range forecasting, and I'm going to MIT. As father of chaos theory, he's one of my advisors, John. So I'll tell you those stories, and then I'll mention a few things about other experiences with the IMD, and then I'll come back to
to the science part. Okay. So that's why I say I've told her to give me notice that what it is. Okay. So I should say it's not that 58 years ago I worked 5 years alone. No, I have been very much involved. I really am very much enjoyed this interaction, okay, over the years, sometimes more, sometimes less, including scientific discussion. Just only a few years ago, a group of scientists from my group came and published it. They said they have a problem with this paper by Goswami and Sahai. Goswami is my great friend, but we have different opinions in science sometimes, which is very healthy. So we wrote papers, we did, so that both are published. Here's the paper, here's the opinion. So I'm saying it's a genuine scientific collaboration. I think many years ago, Dr. Krishnan came to visit. When I was at NASA, Dr. Goswami came. That's where we wrote the paper about predictability of the coupled model, because I was doing only predictability of this. So anyway, this is really a great opportunity. So I just want to young people that I'm not showing my own experience with the research. So I was afraid when I prepared the slides, it may look like I'm sort of trying to brag about what happened. Please don't think of bragging. Think of it that, somebody, Krishnamurti says, coming home and just telling your home, hey, look, I've done certain things. But then I'm not just saying that to do certain things, but there is a message about how scientific ideas develop. So I've chosen 3 scientific ideas, and I'll talk about that just briefly, each one of them. So I really think that the part that I find interesting is how when I came to IITM, and before I start showing slides, I can just tell you 2 stories that again many of you may not know. I didn't study meteorology. Okay, I didn't study meteorology. I studied exploration geophysics in BHU. Meteorology, you take 1 paper, and I was working in Oil and Natural Gas Commission at an oil rig. But somehow from BHU, I had applied for some job without knowing what it is. You never heard of IITM. They got an interview letter to come to UPSC. And my roommate in Dehradun also got, he was a physics student. And I was about to throw that letter. I said, this is from meteorology. We are here. He said, no, don't throw. I have also got. No, you should come. I said, but they will ask me questions. And I don't know. He said, no, but you'll see, it's good for science. I said, why do I want to spend all the money? Science thing. No. He said, you will get a 2nd-class train fare, UPSC gives. But everybody goes by 3rd. And by difference, you can have per diem. You can eat food. Then I said, where will I stay? I said, you will stay at my house. He was from Ghaziabad. So this is an honest story. I said, okay, I'll come. I stayed with him. I went for the interview. Do you remember when you know you are not going to get this job? When you know there's absolutely no chance, you are here only for per diem, not for a real job. You are so relaxed about it. And I think this, I don't know, God bless the UPSC panel. They will ask me questions, and my reaction will be, really, that's so. And then one of them asked me that hill, when you cut it into the middle, there are concentric circles. I still remember that question. I've never heard that before. So this is what I heard. I said, oh, I didn't know that, but let's think about it. And honestly, I was sitting there. I said, let's think about it. Maybe at the sort of small things rising up, going up because that's how it went. Maybe it's depositing more water. It's just, and they were looking at each other. Oh, so I probably fooled them because they thought this guy can think about it. So anyway, guess what? Next thing I know is I got the job. Okay, and I came, and for the first 6 months, I didn't know what am I doing here. And my roommate here in Pune was preparing for IS, and he said that IS can be prepared for this report. And guess what? I started preparing for IS because I knew nothing. Mr. Roti is such a great man. He walks around the office. And he said, how are you doing? What are you saying? And again, see, this has been my habit from, and I'll tell you more story about it. I just tell the truth. And sometimes it sort of works, sometimes it doesn't. I said, sir, sorry, but I'm preparing for IAS because I don't know which one. He just looked at me, didn't say a word, went back. When I told my friends what happened, they said, I can't believe you have done this. I can't believe this. I said, guess what he did? He goes back and recommends me for the UN fellowship to go to US and Japan. And the letter that came from, not letter, those used to be TP, came from DGM. Bisopla has been selected. Look at the coincidence. It was the same day my roommate got rejected in his IS exam. And I just talked to my family, my friends. America is a chance. Really, what happened, I got, and we managed to develop a small barotropic model. But we used to run, not run, what should I say, take a train to TIFR, okay, to run the model and to come back. And one day, it just occurred to me, just going back and forth because I had why can't we ask somebody at IITM staff, there are a lot of assistants, that they will go every day because you have to wait overnight to get the output. So all of us will keep our punch cards ready. So I asked the staff to make a leather bag, just fitting the card. So all of us will give him a card. He will take the morning train and bring back the evening train outputs from the day for yesterday. So I take some credit for creating the first remote computing in the much faster than whatever it was. Anyway, I really would like to then give you, sorry, I was supposed to plan my, how much time I have already taken, because this is not part of my time.
We have 25 minutes left.
I have 25 minutes left. All right, good point. So now we're going to a very fast speed of, so I just said, okay, can you put, I don't think I knew much, okay, about meteorology. And I had met Chani in another meeting, Tokyo, and I don't want to go into that long story, but in very brief, that IMD had sent me to this NWP symposium. Anybody, nothing. It's just, of course, one difference was that my paper was accepted. Then, and the DGM was not keen on sending those two people. That's what I was told. Anyway, and then I met Chani because I was trying to present some paper which sort of criticized his work. And I didn't know who Chani is. So I asked somebody, Conrad, who's Chani? So they showed me. And then I found out he's the most famous man of this meteorology. And then I finished my presentation and I was so relieved. Then he said, I have 4 questions. And then I sort of went back and forth. And all the room was stunned. There were like thousands of people. This was an international conference. And I thought, oh, it's over now. Then he came to my table during the coffee break. So I want to give you another paper I have written. That is the moment that changed my life. I said, you know what? When I go back to IITM, I'll try to apply to study at MIT. That's really what long story I started and I applied. But then once I was at MIT, actually at MIT, there were a lot of opportunities, and some opportunities come and some opportunities, basically you have to take. TM Cole came. He was the ambassador, India's ambassador. And he said, oh, anybody has any ideas about what to do? I was a graduate student. And I raised my hand. I said, yeah, I have one idea. I said, IMD needs to be improved. Oh, what do you mean? So this has been my habit from the beginning. I speak out. I just say if something has been done. Some people get mad. Sometimes it works. Sometimes there are many examples I can tell you where I have to pay a price for it. And then there are many examples where it's successful. But in the end, I feel you're more relaxed if you just stick with the truth and whatever you think, then you can justify it. So I told Kian Cole that is IMD. I said, why? Why do you think it is? And I had heard in Pune that DGMs are selected by seniority cum fitness. I never heard this word before, seniority cum fitness. I said, that's just the opposite of any excellence. How do you bring excellence at the top? If the only way you can get at the top is by seniority cum fitness, you can be mediocre whole life and then you can become head just because you're senior. And I remember I was so young, I joined here And people will tell me, "Tum IMD mein jao, if you go, you'll become DGM in so many years." That's the, this is this is part of the calculation. So he wrote to the Prime Minister about this, and then the Prime Minister set up a committee called Ramanna Committee to examine this aspect. And I was glad to see it was actually changed. And, that system was changed, that it was going to be a direct recruitment for the region. So many times you take small actions, and it does have, my own plan was to really return back to India, by the way, and I will not go into the detail. I was offered, just after his PhD, to be the assistant director of FRD, St. Sebastian Research Division. But India's emergency and what happened to my family, there are many personal reasons I can't come. But I continue to work with IIT all this time. Just regularly, people will have, I'll do that. So I don't think that I have time to really go, but it has been really, my work with NSAP helped me sort of bring the weather forecasting model to NCMRWF. Again, by pure coincidence, suddenly I got contacted by Coworker that they're trying to buy the supercomputer, and I got so excited that, see, nobody will pay for me to travel. Nobody will pay tuition for my children if I stay in Delhi. But I was so excited about the project that my wife went to her parents and we rented the house, and so that was producing enough income. And WCRP, they decided to give my airfare. So I came 14 times in 18 months. And every time I'll bring a tape, I'll bring a software, I'll bring some equipment. But Walker had told the Prime Minister it would take 3 years. I think within 18 months, we made this operational. And it was one of those big, you feel good about, you see something, suddenly change really the nature. For the first time, the global gravitational model. Then, of course, continued that collaboration with IITM, came several times here. I think Hemant Chaudhary from here came to Kola, and then I worked with NSAP. Let's see, I don't know, you can hear me, right? Yeah. I am assuming this is only to protect me, not. So anyway, and we got started with it. Dr. Krishnan came to Kola many years ago, I remember, on this. So it really has been a, but again, I got a phone call from the embassy that Dr. Manmohan Singh wants to meet with you. So I met with him, and I told him what is on my mind about the weather and climate change. It was 2006. And when he came back, he really created a new Ministry of Earth Science. And he and Kapil Sibal made me the chairman of the IAP panel. So I was very involved year after year, we'll have many times than this. But then I was surprised that Prime Minister Modi then appointed me to the climate committee. He's the Prime Minister responsible on climate. I don't think I remember any mail, but I don't get any invitations to attend the meeting. Last time I attended the meeting was at Paris Climate Conference, which was great because I was the Indian delegate to in the Paris Climate, because there's a member of the Prime Minister's committee, so you can go really inside. So anyway, just to end this part, because I really need to talk about the science, my affection for India, for Indian institutions, there are many other institutions I work, my village, my family, so that, I have come at least 100 times back to India during this time, because I make that, the only haven't come is last 3 years or so. So, all right, I think that, let's just go on to, so that was nice to meet Charlie, Lorraine, he was my advisor. I'll just fast forward. Again, chance meeting with Salam. So I managed to create this group, and we have. And IITM had many, many years of joint program, and I hope that someday IITM will start again. Okay. So there are many, many meetings, and so he's my fourth advisor. So Charlie and Phillips were advisors. Phillips quit. You guys might know, went to NSAP. Then Charlie at MIT had 2 advisors. Then Charlie went away, and then they made me go to Princeton. And then Manawe became my advisor. Guess what? Manawe is the first one for our field, which is a great thing, by the way, for our field. So, all right, I think that you're sure I have only 15 minutes left. Is that correct? Yeah. Okay, all right. So let me just tell you about 3 ideas. And the reason I'm telling you about these three ideas is because I know how do the ideas come and how do reanalysis is one idea. And you don't have to go into this. October panel was looking for some way to organize data. And I happened to be in NASA. Simulation is not my expertise, but I saw Halem and Colney were doing it. So they were looking for ideas. So I just wrote 5-page idea. Now, why don't you do the analysis? And guess what? It just slowly it caught on and then it become, now it has become a major source for building. The idea of the seasonal prediction is really what I feel very interesting. And there again, I have to tell you something to do with the background with the village. I have experienced the monsoon droughts. I was not in meteorology. Monsoon droughts cover the whole country, very large areas. They persist for the whole season. So I couldn't believe that such a system will not be predictable. So I just want to be very clear. It was not my insight or some deep knowledge. It was intuition and my general belief that nature cannot be so cruel. So there must be predictability. And we have to figure out how to exploit that predictability. But I couldn't work on it as a thesis topic because you can't do all thesis at MIT. So I did my usual two-level linear instability problem, but the instability of monsoon depressions. So I think that to give you the simple idea, I had done GFDL model, Arabian Sea experiment, and then I had saw at Princeton, I was just walking around in the corridor, and this guy showed me the snow data. And when he showed me, I saw it just upside down in rainfall. And so we wrote a paper, and it became kind of important for cryosphere people because they didn't have it. So when Charlie told me I'm going to India, and I have to talk about monsoon, but I don't know much. I mean, he knows much. I haven't done anything. So I told him that, you know what, India is interested in protection, and here are some ideas. And he got very excited because he himself had done an experiment with albedo. And he found that if you make random perturbations, changes are large. And just in that one conversation, that became an idea for his presentation. And that's what it was done. And those days, nobody believed this possible. Just remember, okay? I was involved with this meeting in '82, and WMO will not agree to make the title climate prediction. They said, no, there's no basis. But then finally, we negotiated and they agreed to do it, physical basis for climate prediction. So anyway, I think many of you know the basic science behind it, and I will just go so fast that if you know already, doesn't matter. If you don't know already, doesn't matter either. So that's, I'll just tell you is that the main point is that there's a lot of persistence. Long waves have a lot of memory. So you can have some sort of predictability means memory. Okay, so even without ocean, you have memory in the long waves. That's why you can predict. With ocean, you have the memory in the upper layer of the ocean. With land, you have memory in the solvents. So these are the three sources of memory. And that's why we get the predictability, but we have to show. So the reason the way I showed was, I have named it billion butterfly experiment. Because people, so it's the same paper, but I'm telling you what I mean by billion butterfly experiment. In a butterfly experiment, you make a random perturbation and see where the model goes. I said, no, I'll make as large a perturbation that a billion butterflies cannot do. See what happens. So I took the initial condition in 83 and initial condition 88. And you all know these were the two extreme initial conditions, okay, of the atmosphere. And look at the southern oscillation. Look at how extreme they are. Take that initial condition and run the model. Guess what? The solutions converge in about 10 days. So what happened to the butterfly? So I always use that in my class. Magic. Think of a guess. But this is the wind in the tropics. What about the rainfall? Look at the rainfall. Seasonal mean rainfall. It's the full GCM. Okay. We're starting with two initial conditions which are completely different. And they're converging. That gives why they converge. And not only tropical rainfall, but look at the extratropical circulation. Converge. Okay. So I get this excitement among the students. Try to guess why, what happened. Guess what? This is what happened. The only thing I was using same in the two models was the SST. So the tropical SST was the observed SST one of those years, that year of 83. And then we just met with them. So just that's the basic idea of that, why there are exceptions to the butterfly effect. That the boundary effect is so large that you can actually overwhelm. So I'll just fast forward. Then you ask, how about the ocean? That's the tropical atmosphere. Same story. Take the tropical ocean for the same 2 years and force with the same atmosphere. But the initial condition of the ocean is completely different. Guess what happened? It converges in 4 months. So what converges in the atmosphere in 7 to 10 days, which is really the tropical atmosphere directly responding to convection, is in ocean. So that shows right away there's a memory of the upper ocean. And you can predict at least up to 4 to 6 months. So these are the ideas that really came to, and I don't want to go into more detail. Land was really another one that is very important. Nobody believed land is important, by the way, in 1980s. So again, this was an idea that I got by reading one of the Chinese papers. So Yale Menz and I said, let's do a crazy experiment. Let's make the whole world parking lot. Whole world. And then let's make the whole world vegetation. Just we can do that in tomorrow. Run. Look at the difference. Guess what? These two full GCMs, the difference, just by changing the ocean is same. Just by changing difference in the temperature, 20 degrees, 30 degrees. So it showed, for those who are not convinced, that how important land is. And this is something that it took some time for people to recognize. That, the evaporation from the land alone can explain 60% of the rainfall over land. So evaporation from the land is a very big factor. It's not that all the water comes from but which molecule rains and which molecule evaporates, that's something that you have to study. But the number-wise, the budgets, 60% of the land rainfall you can explain by the 60% evaporation. All right, I think let's just go on. So, by the way, so polar people have done and shown that land initial conditions can contribute a little more, not as much as tropics, but I don't have time to show you. The main result they found is that initialization of soil wetness. That's something we can pick up for the afternoon session. Is very important because without that, and the only way you can do that is with very high density rainfall spaces. 5 minutes, okay? I'm getting the signals, all right? So, well, I wanted to talk to you about the current skill. Where are we, okay? And I had a 65-year results. And situation is not very good, as Keswamurthy said. You see, the current scale of SST is very high, correlation 0.7. Current scale of rainfall, 0.29. It's very small of the months of rainfall. So, and if you can predict the SST, so that's a challenge that we should discuss in the afternoon session. And these predictions are very good. By the way, this is the prediction of 72 by the same model. So I've done it for 65 years. Look how good it is. But this is, of course, done today, not in 72. But if you look at the 727, it's wrong. So that's another challenge for the afternoon. Why the boundary effects sometimes work, sometimes they don't work. So but in general, seasonal prediction skill is going down in the Eastern Tropical Pacific. But there are many good scientific reasons. Is it to do with the systematic error in the global warming? You can do that in the afternoon. Okay. But look at the story of weather prediction. It's going up, not for the seasonal prediction. So we'll come to that. Okay. So I think that we should, that's why we have to focus on improving the model. By the way, some people, when I say that, some people say, oh, you already find excuse why the predictions are not so good. No, we have to. The problem is that our models have such large systematic errors. The fact that that doesn't interact with the signal, well, that's our good luck. That's all I can say. That still we are able to make predictions, but we should improve that. But then you all know about the modeling summit. We are actually really trying to get countries in the world to unite, and we are hoping that eventually the world will have a climate summit. That's the idea that we have. And now, this is unfortunate, but the next set of slides were entirely about new results. So if someday in future you can tell, but a new result in one word is that Indian Ocean SST is very important. The heat sources along with Indian, and that actually could explain a lot of things, not just the Pacific. That's just the one word message, okay? The second research was intraseasonal fluctuations. What do they do? And these are the ones that were converted. And we have this notion that, interseasonal variation, break monsoon, are very different during the drought years and floods years. It's really not the case. If you look at the numbers, they look like, but if you remove the seasonal mean, they become identical. So this is the doing a bootstrap. So we really need to understand what it is. What is the contribution of intraseasonals? And again, Krishnamurti has done a lot of work, which I'm not going to go into this. But by looking at predictability of the intraseasonal variations and the seasonal mean, that's the framework that I was going to discuss into we can talk about it in this. So I really think, look at the intraseasonal IOE and ENSO. They totally explain most of the same. But we have a problem in predicting both the ENSO response as well as the intraseasonal response. So that's our challenge, how to do that. So I think that I've given you the summary. I really, that's a challenge for afternoon. We really have to do that. Let's do. I think that I really will like to, again, conclude by congratulating IITM for doing such a wonderful job. And I was trying to keep this a science talk, so I try to keep 1 minute for questions. But so thank you very much. And I'll stay for 1 minute if you have any questions. Thank you. Thank you. That's a comment. I can question.
There's one question.
Well, I know Surya is going to say, you always say the same thing.
So, how do you make this 0.29 to improve? What is the critical? You have shown that the JJ's seasonal mean friction scale is 0.29.
Yes.
Whereas ENSO scale is about 0.7.
Right.
So, what is the major component that needs to be?
Okay, so three things that ENSO response itself is a very strong function of the actual structure of ENSO. Is the heat sources in the Eastern Pacific and the Central Pacific. So first of all, the model has to get that correct, number one. Just because you have linear 3, correct, that's not good. So that's number one. Number two, the remote response of the forcing and traffic depends upon the medium through which that response has to travel, right? Just a simple dynamical theory, right? So if you have an error in predicting the large scale flow through which the response has to go, then that's another thing you have to improve. So a lot of people are working, just like Indian monsoon. 72 was great, but 97 was very bad. In the California floods and droughts, one ENSO gave a perfect focus. California, it is a big response. Another ENSO gave completely opposite, just opposite, negative. And that's one of the angles. I mean, some people always say, oh, it's butterfly effect. And I feel butterfly effect should be the last refuse when we cannot understand something. Okay. So that's the second point. So these are and I have been, and by the way, since you asked the question, I'll just tell you that the only way to pin this down is not by doing 30-year forecast, 60-year forecast, 50-year forecast. That's good for writing a paper. So, of course, my people, they had to write a paper. So they wrote 60-year forecast. What I have suggested to them is that, no, take 1 year and get 5 modeling groups and do case studies and try to pin it down exactly what happened. Was the tropical heat source was wrong? Or the medium was wrong? Why it didn't get it? Try to change convection. So this is something I was going to throw an idea at you. Yes.
Yeah, so you have that one point you make, we have not reached the potential of predictability, both in short and seasonal prediction. But in last 40 years, you have shown and we have seen that we have achieved a lot. So what is that one liner that what we have achieved in 40 years and what we have not achieved?
Oh, well, I mean, that was sort of I was trying to hint. I mean, what we have achieved is just unbelievable. I think when Dr. Ravichandran mentioned, someone mentioned, look how better our medium-range forecasts are, right? 10-year forecasts are. Okay? And the seasonal forecasts are much better than what we used to do. So when I was criticizing, I was saying the progress is not as fast or as systematic, and that's what it is. But definitely we have achieved, and that's, as Sylvia asked, that's our challenge to find out that what it is. And that's why we need, by the way, I'm going to throw a line. It was supposed to be for the minister, but now the general is here, so it's for him. I mean, you cannot do these things unless you have sufficient computing power. You just cannot do that. And computing is a staff, scientific staff, because you cannot have one person doing 10 different experiments. We need, just imagine the number of people at the European Center who have worked to make that forecast improvement. So that, I think that is we have to keep pushing. It's like a wall, okay? It's not moving. We just have to push it. And we have to push it with all the computing power and the scientific staff and collaborating with all the other institutions, which we do.
Thank you, sir. Thank you very much.
You have to, oh, yes, yeah. You cannot live without her. Okay, thank you. Thank you.
Thank you so much, sir, for your wonderful talk. It was indeed a delight to hear him speak. So next we'll move on to a tea break. But before that, I would like to mention that following the tea break, we'll be having our brainstorming session on improving monsoon forecasts in a changing climate. So as we all know that monsoon is of course our country's lifeline. And today we'll have this opportunity to listen and discuss about the various research and challenges in this field from many of the dignitaries and pioneers of our field. So I request all of you to please come back after the tea break, and the tea is arranged in the basement of the Meghdud auditorium, that is this auditorium, and the Niturang building, which is also known as the canteen.
15 minutes, how much time?
15 minutes.
So what time we should be back?
15 minutes.
11. Please come back by 11 a.m. Thank you.
Thank you.
Oh.
Act up your feedback. Oh. Sir, look at this thing. Yeah. आपल्याला सगळं करू बरं आता हे बोलायचं तर ह्या स्क्रीनवर दाखवणार इथनं बसणार आहे का प्रेझेंटेशन पण दिसत तर इथे लॅपटॉप पण लागेल
इथे स्विचर लावू का? हे बघ काय म्हणतोय, हा लॅपटॉप इथेच ठेवतो, त्याच्यावरनं प्रेझेंटेशन देऊया. ओके, याच्यावरनं प्रेझेंटेशन ते सगळे डिस्प्ले
सतीश अभी लगा सकते
हाँ यूट्यूब वर जाऊ.
I think the facts are understood. We always tell people how you guys are so nice. And
आप सभी ने ना मेल पे भेज दिया, इसको पहले भेज दिया नहीं, आपने लिखी बाकी सबका लिखना चाहिए था. आता ते थांब रे, स्क्रीन शेअर करा, स्टॉप कर, स्क्रीन शेअर ना गेले, शेअरिंग स्टॉप करा. बट ये मुझे शेड्यूल में बताइए कब टाइम में डाल दो, क्योंकि मुझे ये नहीं पता तीन बजे 3:20 को उसी को क्या कर दूँ? हाँ, क्योंकि वो मुझे पता चल जाएगा कब इतने सगळे फोल्डर घ्यायचे ना, हाँ
सतीश ये बिल्कुल ये IITM में वाईफाई नहीं चल रहा, वाईफाई नहीं चल रहा.
17 नोव्हेंबर त्या अजून एक लॅपटॉप कुठे आहे? त्या लॅपटॉप मध्ये बघ बरं, ज्यांचे त्या नाही, त्या लॅपटॉप मध्ये हे नको रिकामा आहे लॅपटॉप. ठीक आहे त्या लॅपटॉप मध्ये किती फाईल्स आहेत बघ 17 नोव्हेंबर मध्ये. आम्ही सांगितलं होतं हे मग त्या बोलायला सांगितलं का? नको राहू दे, गरज पडली तर, का लोक आता एवढे सफिशियंट. वो नहीं बाहर के लिए. सर अभी मुझे एक बताइए क्या, अभी ये देखिए एजेंडा ये ऐसा है, ये अभी ब्रेनस्टॉर्मिंग डिस्कशन होगा, तो उस समय पे यहाँ पे लैपटॉप चाहिए.
पसंद कर रहे हैं.
हाँ, तो वो बैठ के ही करेगा,
बैठ के
उनको मैं स्लाइडर दे दूंगा, वो स्लाइडर आगे आगे कर लिया. सो वो फिर वो ये कर. अरे भाई सुन ना, हेलो मुझे ये सारे कनेक्शन वहां पे मिल सकते हैं ना? वो मेरा मैं HDMI निकल के दूंगा और वहां पे लगा दूंगा तो हो जाएगा. पर किस चीज का है
सतीश माली मेरा देखो ना
ये
ये
मैं
नहीं
ये
चल रहा,
प्रोजेक्ट
आईडी बेस्ड भी नहीं चल रहा है।
तो मेरा जो
देखो
टेबल था ना
नहीं चल रहा।
वो वाला जो है ना वो वाला टेबल वहां पे लगा देना हाँ उसमें लगा दो सब जगह
मैडम एलिवेटेड दो टिपो है ना ये नीचे टिपो है ना इसका
बरं असं अजून एक स्टँड आहे का आपल्याकडे
जहाँ पे ये रखा था
अरे
टेबल वो रखा था ना इसका सामने
आप देख लीजिए इन पूरे हैं वहाँ।
दो लेके आओ ना दो
हुआ क्या 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 हो गया था साइड कुछ
फ्लाइट सर देखो सबसे सरल ऊपर है ना चालू सोफा
आवाज
Can you start? So, request our dignitaries come as please. So, Professor Rajan Krishnamurthy, Professor J. Shukla, Professor Gaur sir, Dr. Rajivan sir, sir, please. Professor B.P. Rao, Professor Ravi, Professor Ravi, and Dr. Mitra. Dr. Ravi, Secretary sir. Yeah. Thank you so much, sir. And as it was mentioned in the part, this session, first the director will show few slides to the dais first, then we go to sign experts, dignitaries, and then we go to first. Remark.
Good morning, all. I'll just make a short presentation. Present.
Yes.
I'll just take it. Not able to see.
Sir, just a minute.
So, good morning. Today I will be making a very short presentation to set the stage brainstorming discussion. So I just take an example of the 2022 monsoon. We see rainfall variability, large spatio-temporal variability, the rainfall, which was, and also many extremes, very special case. And this we can see that many parts of peninsular India peninsular and central India got excessive rainfall, and large area over the Uttar Pradesh, northeastern parts of India and Bihar and many states, they were highly deficient. So it had big impacts on the agriculture, the crop production, and so on. And it was very persistent. If you see, so India as a whole, the rainfall was normal, plus 6% above normal. But you see a large spatial variability and also temporal variability, because if you see northeast and northeast India, it was excess in June, and by the end it was plus 22%. And by the end of the season, it turned out to be minus 18%. There was a large variability. And also, for other parts of India, also you see the variability. But and also on the intra-seasonal time scale, June was excess over the eastern northeast, and later on it became deficient. So that is the point. And when we look at the larger spatial pattern of the observed rainfall and SST anomaly, this is for June, July, August. Again, the same picture is reflected, but the rainfall deficiency is extending into many other places, into the Philippines region and further southward. And also large areas in China, east parts of China was deficient, and southern part of China, but northeastern part of China had excessive rainfall. Also, you can see the rainfall shifted more west-northwest towards Pakistan region, which experienced a lot of floods, heavy rainfall and flooding. There was also a La Nina condition, very persistent La Nina during 2022. And when we look at the long lead forecast, the slides was provided by Subodh and Hemant. The models, by and large, the coupled models will start from February initial condition or March initial condition, April condition. The large scale pattern of rainfall deficiency in the eastern to the east of Philippines, you can see, and in the further westward in the eastern Indian Ocean and over the Indian region, there is above normal precipitation. But the model fails to capture the kind of variability over eastern part of India, also over China and China region. So the large scale, there are many elements the forecasts are missing. And so why I am highlighting is, if you see, China also received experienced heat wave, record heat wave during July, maximum temperatures crossing 40 degrees in many places. There was a severe drought in the Yangtze River Valley of China, and Europe had experienced heat wave, and of course the Pakistan had heavy rainfall in June, July, and August. So we see a lot of so the extremes are happening, and this was an article from the Nature why the Pakistan floods are so extreme, and it was followed by this heavy rains were followed by intense heat wave and a long monsoon that has dumped a record amount of rainfall. And there are signatures that because of the warming during the May and June months, the record-breaking temperatures and the heat waves, the glaciers also melted subsequently, and they contributed to the runoff and flooding. And also because of the increased water vapor amount in the atmosphere that produced a lot of rainfall. In addition to that, there was the monsoon synoptic systems, as well as the prevailing La Nina conditions were contributed to the rainfall. So it's a very complex mix of all these variations within the natural variations in the climate system, plus the climate change impact. But no systematic attribution has been made. That will require a separate study. And this is, as we see, the decade by decade, the temperatures are increasing globally. And 2011 to 2020 is the warmest decade on record. And we know there is very strong evidence that this is because of the greenhouse gases. The warming has been happening, and especially the polar and the high latitude regions of warming. And they are contributing to extremes. So one of the slides which Professor Shukla mentioned, so I just borrowed from him, this contribution, what is the contribution of ISOs in the JJS seasonal mean rainfall? This, and he said, the answer is, this is a very difficult question, that's what is mentioned. The one point is that when we look at on the intra-seasonal scale, the spatial pattern of the convection and the rainfall anomalies, they're extending from the Indian region all the way across into South and Southeast Asia. And these are very large scale patterns of convection. And so the question is, if we want to, this is something that occurred to us, maybe we have just proposed, we are just hypothesizing this. We would like to get the feedback from the August audience and experts. Basically, if you want to improve the forecast in a changing climate, there is an operational requirement. It also needs to be backed up by research, and in fact, that both have to go hand in hand. So one possibility, what we are thinking, is that we could have a short-term plan for the next 3-4 years in terms of a coordinated both observational and modeling experiments, focusing on the South and Southeast Asian region and the East Asian monsoon regions. We could have intensive observations, radio sondes 4 times daily, surface observations, radar, satellites, ocean. And we have to involve the operational weather forecasting centers, research and academic centers, having data assimilation and construction of a special reanalysis data set, which could be used for the impact assessment models. And we also have to improve the models and do model experiments to understand monsoon predictability across scales and the interactions across different components of the climate system. There could be various science questions on the role of land-atmosphere coupling, on the role of ocean-atmospheric coupling, and in fact, influence of climate change. Because we know climate models are able to produce the extreme temperatures and the extreme precipitation in response to the increased greenhouse gases. but can we do event attribution, especially in the monsoon region, focusing on specific events like the heavy rainfall and flooding in Pakistan? This will require large ensemble of simulations. Maybe the IITM Earth System model is one of the potential candidates. We will check that. We also have to improve the model representation of key physical processes in weather and climate model. And in this regard, because already IITM is having many observational programs like the Central India Test Bed, the High Altitude Cloud Physics Lab, the CAPEX, and so we have learned, so there are observational programs as well as the modeling programs. So IITM would take a leadership role in conducting this project. And also now I just want to highlight that Asia-PEX, this is one important experiment led by the Japanese, very similar to it is related to the WCRP JUX, which is focused on understanding the Asian land precipitation over diverse hydroclimatological conditions for better prediction, disaster reduction, and sustainable development. And one of the speakers today, Dr. Toru Terao from Japan, will be presenting a few slides on Asia-PEX. So we can have a kind of a partnership with countries in the Asian region and maybe other partners to address these strategies, how to do this coordinated observation modeling experiment. And also in the long term, develop and implement a science plan for improved understanding and prediction of monsoon and hydroclimatic extremes in a changing climate. We can develop a short document. And with this, I want to end my talk. Thank you very much for the time.
Yeah, thank you so much, Professor. And actually, one line summary is that while we are facing challenges in various, enhanced model prediction for different scale of monsoon predict, to take advantage of observation that is happening beyond Indian boundaries, along with the observational campaign that is happening within India. So I will request Professor Toru Terao, who is joining online, to come and share his slides and give a very brief on Asia-PEX and related this thing.
Thank you very much. Can I talk now? Okay. I'm Toru Terao from Japan. So now I talk about some introduction about Asia-PEX and also some future plan for launching some observational and modeling initiative by this Asia-PEX. So can I see my slides, or can I share from my side? Can you hear me? Okay. Okay. Thank you very much. Yes, and firstly, I like to thank to all the people in IITM to giving me this very big opportunity to give talk in this great session. And on behalf of our colleagues in Asia-PEX, I'd like to send big congratulations to the 60-year anniversary of IITM first. And IITM very important, and so if my university allows, I want to go to IITM and staying 1 year or so and making research. And I know that there are so many nice researchers in this institute. And every time I go to IITM, I enjoying this discussion with all people in IITM. So thank you very much for you. Now I'm talking about this topic. And Asia-PEX is just already been introduced by Krishnan-san. We are under the JUX perspective and other WCRP. And Asia-PEX is one of RHP, one of prospective RHP in the GHP program. And so we launched this project in 2019, and now it's been going on in 10 years or so. So this is some successor of game and Mahashri project, and we are now running this project. So I'm one of the leader of this project, so I'd like to talk this here. So please go next. Next slide. Okay, so this year I went to many places in South Asia, including Bangladesh, Nepal, and India. It was very nice to me because it was 3 years I can't come to South Asia, but now I can go. It's very nice. And the last phase, I go to IITM and so discussed with Krishnan-san and Mukhopadhyay-san and Pandit-san. He had a very nice day.
Hello.
Next slide.
Terosan, can you use a headphone instead of your laptop speaker?
Right. 다메다. 聞こえない。全然。Sorry, this device may not work now. Can you use this? Sorry. Can you hear me now? Okay, yes, then I continue. So please go to the next slide. Yes, this year, the people in northeastern India experienced very severe drought and also severe flood also. And they experienced severe flood in pre-monsoon season, basically. And after that, they experienced very severe drought. The next slide. So I checked the rain gauge data from our own project in the Guwahati. Guwahati is the northeastern part of India and Assam region. And we can find that in the very recent years, that rainfall in the pre-monsoon season is still high, but the monsoon season rain is somewhat decreasing. And people are saying that in recent years, the pre-monsoon rain is increasing and the monsoon rain is decreasing. And I checked some data, and the result is somewhat consistent with this feeling of the people. And I don't know, it is clearly the result of the climate change or not, but there has to be some change, and it can be some symptom about that new climate change impact. So we should make research about that. And we have many collaborators in northeastern part of India, like Cotton University and IITM and IMD and NISAC also. And also in Bangladesh, we have collaboration with the University of Dhaka and BUET and BMD and BWDB. Please go next. And the University of Dhaka will have the very conference in the next month, so we can discuss about this climate change in that chance. And this is our current status of the apex in GX, and we are now the prospect RHP and the GHP of the UX perspective. Please go next. GHPs and the GX, as you know. This is very near to the land surface processes. Please go next. And AsiaPex has already done the kickoff conference in 2019, and we had many guests from many countries, including IITM also. There are some people in IITM. Can you find it? So we had a very nice discussion there. Please go next. In South Asia also, we had some plan to develop AsiaPex South Asia. We had a discussion in Kraj, Rajasthan, with the lead of the Someshwar Dastan. He's coming here. So we had a very nice discussion there also. Please go next. This is the main objective of our AsiaPex. So understanding ASEAN land precipitation over diverse hydroclimatic conditions. So it is very diverse condition is there. So very big topography and also so much different type of vegetations and also the soil situation. So we have to think about the very complex land atmospheric interaction in this area. Let's go next. And we take the approach-oriented strategy in our AsiaPex, not regional, but the approach-oriented strategy. We summarized our approach in these 6 ways. One is observation and estimation. The second one is the process study and land atmosphere coupling. The third one is the predictability of the different time scales. And also fourth one is the hydrological modeling. And fifth one is the synergy effect. It indicates that to launch some modeling and observational initiative to collaborate. Sixth one is the future climate projection. Please go next. So now we go to some recent achievement in our project. And I think there are some common characteristics in our development and success research activities. One is a combination of institute meteorological observation and also combined with that the large-scale instruments also, including satellites. And the second one is the very clear. They have very clear target of sub-regional, some smaller region hydroclimatological processes. And also, they're using the very large data set, global data set, like the climate modeling or the reanalysis or the satellite data set to combining these results in this research. So this is the one of our research in the southern slope of Himalaya range. And they say it is high-plex project in the north southern slope of Himalayas. They found a very clear diurnal variation. They have 2 peaks in rainfall in diurnal variability in the southern slope of the Himalaya plateau range. And they combined these results with the observation using the satellites and also the analysis. They found that the clear change in the atmospheric circulation pattern in the 2 different peak times. And the process is different. The peaks in the 1 to 4 p.m. is rather lower slope, upslope wind, very important. But in the evening peak, that the wind acceleration is lower troposphere is very important. It's impinging that slope and it makes very strong rainfall. So that mechanism is very different in different peaks of the diurnal peak of the rainfall. Please go next. And also, in this case, they are very much focusing on the southern slope of the plateau. And it has a scale of about several 100 kilometers. And they are focusing on the process of some mesoscale structure. and they try to understand the processes very clearly, focusing on these small areas. So this type of the concentration to that the sub-regional activities makes me very important to understand that the process of that the very complex hydroclimatical systems. And please come, maybe time less. Okay. And now we can summarize, and Asia Peaks will launch in future some observation modeling initiative. So our strategy will be these 2 points. One is sub-regional coordinated observation platform, very important. We can focusing on some sub-regional regions having the mesoscale scales. This is very important one. And other one is the integrated global analysis, combining these sub-regional processes. So we think about this to focus have to be very important in the future observational and modeling initiatives. So please go next. Yes, this is my final slide, and special thanks to IITM. I have made some other slides, but maybe no time, so I cannot talk about that. So my message is just that the 2 points I explained in the last slide. Thank you very much. Can I talk some more? Not. If I have some time, then I can explain some more about MY also, but okay. Oh, thank you very much.
We had monsoon trough was very much to normal position and did not move north. So we had deficit rainfall over UP. We have noticed in the last few years there is a sort of dispersion of the monsoon. The rainfall going to Dubai, Muscat, sometimes extending up to that, and somewhat to the excess rainfall over here. This way, I don't know the result of global, but that experts so in addition to the improvement of the models, which are ongoing and which are very complex, you will be undertaking, I have a suggestion that we don't give up completely our statistical forecasting. I mean, this is maybe it's less fashionable, but you may improve statistical forecasting also with techniques of AI and ML. I would suggest, in addition to as another, yes, of course, model improvement. Finally, the numerical models have to be the answer. I would also suggest that we do that. Thank you.
Thank you so much, sir. Insight. May we request Professor Shukla give your views?
Okay, first of all, I'd like to say hello to my friend and remotely connected. I see Dr. Swami is I was talking this here. Is there? Is there? Dr. Swami, thank you for all you have done for enhancing, okay, and particularly the IITM, particularly conservation, for the kind of idea, the science. So I told him like that when I was here, everything, but you have to respect science contributions. So when it comes to the proposal, since I have only 3 minutes, be very fast. I completely and wholeheartedly buy your proposal. I tell you why. That most of the experiments are on the observational program, and I have been involved in many of them in the last 4 years. And I'm not a modeling expert. I sort of, because I'm always modeling, but the observational panels also invite me as a token, Brahmin, in their observational and modeling. So I get to see both. This is a great idea. It should be a coordinated spaces and modeling. And so I think it should go full ahead. I suggest, but I have 3 kind of, not criticism, but 3 comments on this. You cannot be sort of ambivalent for 3 to 4 years. I think you should say it's a 5-year program. Okay? I mean, you should do. Second thing is that you should launch it, worry about how many other countries are part of it, but then try to include and try to suggest that the finals, the WCRP as a more broader experiment that other people. And my last quick comment is that I think you mentioned the climate change will be one of the reasons. But it should address at all times. Intraseasonal, seasonal, because see, people have messed about weather capability. But I wrote a very important paper that 10-day forecasts have been a lot. But the reason they have it blocked is because 1-day forecast is good. Okay, this is something that is not repeatable. Because after 1 day, it's just take over. So there's so all the errors in institutions and model. And I have a feeling we have shown that this can apply a longer time. So we have to do 3-week, 4-week, 4. And by the way, the reason we worked on seasonal, there we found a possibility. That doesn't mean that's the most important problem for India. Most important problem is week by week prediction, at least for 3 weeks, 4 weeks. There's a lot of work on week by week forecast, which I know work is. So include all the time scales. One thing that was not in the list, I think, is to include aerosols, because the role of aerosols in both intraseasonal and this, I think, is getting more important. But it's a great proposal. So good luck. Thank you.
Thank you so much, sir, for your insight. May we request give your view. Professor Joe. So we request one second.
First of all, thank you very much. Since the India speakers took less than 3 minutes, so we have. I'll start from weather forecast. We have mentioned forecast starts from short range forecast to seasonal to seasonal and even change scenarios. And as all of us know that we are really good in tropical cyclone. Waves we are doing. I'm talking about the short range. In cold waves, we are really good. And for rain, yes or no, we are good. And also, we are still started quality plus of this up to 8 hours, especially for Delhi. And the main problem is the quantitative precipitation, which is really an issue. Not only in India, the numerical models are built to predict the quantitative precipitation accurately, especially on the quality. And so that is more important because vast birds very, very important. We have not do. We have established the recording system for Bombay that 3 years back. We had serious problem forecast with the that forecasting system is. So once you are input is not ultimately the results are unreal. But now I would like to talk to that. So far, we did the forecast seasonal forecast now intuitively in our supply forecasting system. But the whole wealth of it, especially WMO, is talking about example prediction, starting from hours, reached hours to days, then seasonal climate. So it's a system prediction, a system observation. We're talking about terms of a system. And no more NWPs people are talking. Now it is a numerical, a system, and climate NEW now. So we need we are good. We are lucky because we have a seamless prediction system, two system on the IITM building and one another. It's a matter of playoff. We are on the job. So definitely we can further. So what we need is a little bit more observations. Observation means we really move forward to non-conventional. That is the message coming out because of the cost amount. So people are talking about low cost sensors. For example, might have a mobile phone, 12 towers, getting a rainfall observations and small sensors. And in terms of satellite, they don't have satellites now. Geostationary satellites. They're talking about pixels, nano satellites. So we need to really do some kind of innovation in terms of low-cost sensors, especially non-conventional observations. We need more, especially when we are moving from modern 12 kilometers to 5 kilometers, 2 kilometers. We need more and more observations. When we need more observations, we need more money to cut cost of the instruments. We need to innovate, do kind of a sensors. We have a serious problem with the hydrology. MOAS is responsible for rain which is coming down. Otherwise, sometimes it is responsible for what the water is doing, where the water is, whether it is going down, whether it is going. So we don't have good interaction unless some PM office meeting, we don't interact. So when we talk to the people, they are not shared. So, but you need a kind of a integrated and meteorology and meteorology people should come together. We should not treat them separately, separately. At the right time, meteorology people come together and solve issues. There are so many issues. That's for visualization. For example, good atmosphere independent and cutting iron for some. We want that, need a lot of data. Runoff, seepage, etc. So each is meteorology people have. So we need to really integrate hydrology plus meteorology. And in terms of observations, when I said that public-private partnership will be really good because everything MOAs cannot do it. Dr. Vichalan has a little money, he has to spend for many other issues. So we need to really look for public-private partnership, especially in terms of observations. But we need to really find out private people who don't put the AWS at the 10th floor of a building. They should know where the instrument is to be kept. That's number one. Then, of course, Krishna was talking about physical and dynamical process which need to improve in the model. I also concur with that. Then I will come to the next point is even when we are talking about increasing the resolution of the model, there is a theory which, of course, people like Tim Palmer has put forward is you need not really have a very high resolution for the prediction model. You can downscale using AI and ML methods. And there is a new kind of work going on everywhere to use AI and ML methods to downscale the global model to get a very high resolution regional forecast. So we need to really use AI and ML methods for different aspects. For some pre-processing of the input data, post-processing of the output data, and even AML method can be used to replace the physical parameters, for example, radiative transfer model, etc. So we need to really invest more on AML. I'm happy to see that IITM has set up a Center for Excellence in AML. Hopefully, they will do a lot of work on AML. Then I will come about my favorite seasonal forecast, as Professor Kesamurthy was saying, that we have difficult problems and seasonal forecast in terms of models. This year our forecast was good, but that does not mean we are perfected. We have serious issues in terms of seasonal forecast. Some year it will work, some year it will not work. And I also support Professor Kesamurthy's idea of still persisting with statistical model, but in terms of improving using AI methods, I am very sure that the skill will be more. The problem with the seasonal forecast is still we know only the linkage between ENSO and monsoon. And as Professor Shukla was saying, that the ENSO-monsoon relationship is weakening and the ENSO's influence on monsoon is weakening. So we don't know anything else. We talk about Indian Ocean, we talk about Atlantic Ocean. For example, people like Professor Goswami is talking about multi-decadal oscillation, multi-decadal variation between Indian monsoon and Atlantic Ocean. So we need to really find out more drivers than ENSO, and also do a lot of diagnostic studies how this relationship really work. We simply run the model and just see the output saying that this model this year it was not predicted this year, but we need to really go into the model and see how these diagnostic relationships are really working. The last point of climate change and where system model was developed by Dr. Krishnan, and we should really congratulate him. And of course, they need to really develop. It's the first kind of question of a system model. They need to put interactive aerosol, better presentation of physics they have to put. So I strongly recommend that they should go for a high resolution climate system model. And also they need little more than one instrument. For example, now we have only one run for getting a climate change output. And also we need to what people know more, what people want know more about is the uncertainty involved in terms of climate predictions, climate projections. So we need to really tell the policymaker, because climate risk is involved in terms of climate policies, and climate policy people wants to know what is uncertainty. So we need to really kind of ways to tell them what is more about uncertainty. The last two points is you are also highlighting about climate change attribution. Climate change attribution science is growing. And recent paper 2022 heat waves climate change attribution study was done. But in India, the climate change attribution science is not that good. People are not doing. I think we need to really do. People want to know each extreme events, whether it's really related to human influence or it's just a kind of a natural variability. The last one is Dr. Krishnan, you should have a good climate portal, because people want to know what climate change is happening. Even now, village people want to know what kind of climate change scenarios are happening. So we need a big portal, like for example, what this KNMI climate portal, what they have, and a similar kind of portal I think IITM should have. With this, I'll stop here. Thank you very much.
Thank you so much, sir, for suggesting right from weather to climate change, all the strategies. Now, may I request Dr. Honorable Secretary, Dr. Ravichandran, to give his remarks.
Because we all know that the monsoon forecast, mainly weather and climate forecast, is a big challenge. And when we do something, understand, by the time things are changing, and every time we are only postmortem, we are doing this is what we have done and other things. This is the major things. It is coming from the top level, that is against maybe the forecasting community or the weather community. Yes, there is a change in spatial and temporal variability. Somebody was mentioning that it is shifting the spatial rainfall distribution as well as the temporal distribution. There are a lot of changes are happening. Of course, we need to know, because we should not also basically see that what is the definition of monsoon. It is not for monsoon onset or end. We have to be very clearly defined. That is a very important thing which we need to start. It is not the date, but the physical process correctly we have to mention, because earlier September 30th, maybe around the September it will be end the monsoon. Now even October it is going on. Even many people are started asking that what has happened, whether it is the extended monsoon or it is something different. I think whether the total things are shifted in temporarily as well as spatially, whether it is shifted from east to west, maybe See, we had a very big dipole like Rajasthan and heavy rainfall region in the northeast. But now slowly northeast is reducing and Rajasthan side it is slightly increasing. So what is happening? So all these things we need to have an understanding. So essentially what I want to say is in order to improve our forecast, there are three things according to me. One is, of course, we need to improve our initial conditions. For that, we need to have, as the Rajivan already mentioned, we need more and more observations. In observation, there are two categories. Of course, one is for a very fine resolution observation to understand the processes and maybe improve the parameterization scheme and other things. And other one is the number of observations to assimilate to have a better initial condition. And of course, the second one is model physics we need to improve. Though we are having a high resolution and different model setup and various techniques we are using, but still we are not much put effort in improving model physics, especially when our region, how the tropical region, how it is changing the things. We need to put some effort, more effort in the model physics parameterizing scheme or anything. Of course, the third problem is the amount of manpower working in this domain is very less when compared to other, maybe somebody was mentioning about ECMW and other people, how many people are working and where in India, how many people are working. Of course, we are limited, but what I suggest is, of course, we can always ask for more manpower and other things, but at the same time, it is very important. We need to work with the academic institutions. We are working very detached way. I think we need to harness the academic resources available in the country so that we have to bring it back to mainstream so that they can bring some improvement in the both model physics or various understanding and other things. Of course, the last one is HPC, whatever they require. So we should have maybe in the long run, we should have a big HPC here so that it can be used as a test bed so that where the academic community can come and work with the particular problem to improve or anything. So basically, according to me, three things. One is initial condition. Number two, model physics to improve. And third thing is manpower. So initial condition also, we need to have more and more observation. Model physics also, we need to have a fine resolution observation plus understanding and translate that understanding into the model so that we can improve. And the fourth one is a manpower. For that, I personally feel that we need to work with the academia, not only in India, from outside. We need more and more collaboration. And I think we have to tap the academic potential, what is available in India, so that we can somewhat we can improve in the coming years. Thank you very much.
Thank you, sir. Thank you for your very valuable suggestions. Now, may we request Professor Ravi to give your remark.
Talking about monsoon in 3 minutes is a little difficult, but I'll just talk about things which I may know a little about and not talk of many other things. It's almost impossible. So I'll talk about modeling and how we can improve modeling with data from various sources. As my friend Krishnan said, we have good facilities at Mahabaleshwar and now coming up at Bhopal. So our two different contrasting areas, you're going to get fantastic data. And this data could be used to kind of improve our physics in the model parameterizations. We really don't know about what happens in boundary layers within India or different parts of India or even radiation. We don't know much about it, the cloud interactions. And of course, the most important one, the cumulus parameterization. The clouds in the monsoon core zone could be very different from what's happening in Mahabaleshwar. So all this will give us very valuable data for us to improve our subgrid scale parameterization. Coming to subgrid scale parameterization, now we are kind of moving from high resolution almost to a seamless style where we talk of a global scale, the regional scale, then we come to even shorter scales. And the cloud resolving, LES, DNS. So what we need to do is to concentrate on all these scales, especially LES and DNS, so that we can abstract the information from LES, from DNS to LES to cloud resolving models to GCMs, so that all this information can go in a seamless fashion in both the directions. And that would certainly perhaps, and I don't know, I'm just speculating that it might improve our forecast. Another area which we really do not talk about is using HPC more innovatively. And for that, we also need to talk about dynamical code, which could also go in a seamless fashion. And it should not be like that we are handling things into the models and calling it seamless. All this, and finally, which one of my friends talked about, yes, we need to use a lot of AI engines to also lead to hybrid scale model. Thank you. And happy birthday, IIT.
Thank you, Professor Dodi, for putting very difficult task in a very simple way. So, may I request, Sir, DK Go, sir, give your remark.
At the very outset, I should like to say how happy I feel to see that our short-term forecasts have improved greatly. Many years ago, when this started happening, not many years ago, maybe half a dozen years ago, I asked a question to the then director here that has this improvement taken place due to Ron or due to Brain? And his answer was that's largely wrong because we have more data sets rather than the fact that we have improved the model structures or the boundary conditions. And I think that I believe those questions are still important about the model structure and the boundary conditions, of course, the initial conditions, as Ravi just pointed out. So one would like to know as to what is the present state. For example, if we look at the model structure, one has known for a long time that there are features in the weather system, for example, the cloud physics and the boundary conditions at the surface, which are extremely important. This morning I was told by Surya that even the inclusion of the flowing water bodies has an effect on the model output. So one would like to know, for example, whether we are able to put in our model the soil moisture of the land surface, of which we have potentially a fair amount of knowledge from the satellite data, if we are able to calibrate it properly by using various means that are now available and also use data in order to reduce satellite imagery that come from various space-time scales to some common data. And there are analytical frameworks available today to be able to do so. Have we done that? How far we are away from that? And some of the questions that always intrigue me, and I'm sure that it's probably naive at this stage to ask, is do we ever compare as to how close or far we are from the theoretical predictability? Jagdish Shukla just told me that Lorenz had actually pursued this question to a limit where he published many papers, and we have many insights now to be able to calculate the theoretical limits. For example, using Shannon entropy, as I understand it, which information is available in the variability, and as we have so much data now available, one assumes that it is possible to calculate this. And the question one would like to ask, well, how will we do that? So these are some of the things. Of course, the initial conditions, initialization is extremely important for improving the short term. And how well can we do that? So, for example, stopover like data assimilation do not always convey the full extent of or effort that goes into it. How well are we doing the data assimilation? One knows that one of the big problems with the data assimilation is to carry forward the large covariances of the previous estimate. How well does one do that? What are the strategies one follows? Do we ever examine these things? So some of those questions spring into my mind as I said that. Maybe they're naive and the questions, answers already to those questions which are being implemented. But it would be nice if some information is available on how well are we doing these things. For example, are we using particle filters? That is the state of the science in data assimilation. And questions and responses. Thank you.
Thank you so much, sir, for putting the highlights, physical like soil moisture, etc. So may we request now Dr. Ashish Mitra, head XMW, to give his views.
First of all, I would like to congratulate Dr. Krishnan for the great work IITM has been doing, and thanks for inviting me. So regarding the monsoon forecast, the first point, see, we are very fortunate that we are working on a system which is having world attention. So monsoon is such a complex thing. All the centers in the world, they put like monsoon simulation, its variability is like a benchmark. And tremendous improvement has been done in the short and extended range. But still, what Professor Shukla has been canvassing that we have not reached the potential predictability, at least up to a seasonal scale, days to season. So the building blocks, if we see the model development, the data assimilation, the observations, and resolutions, and the physical process and the stock. So when you look back in terms of let's say observation, to look at the observation monitoring plots, we see a lot of gaps in the West Asia, Africa. So still there are gaps. For example, we know the westerlies interact with the tropical systems, and we don't have anything in the west of India. So when a westerly wave comes, its amplitude, position, they are not well defined. The models, the high resolution models are available, but we have very incapability to initialize the model in terms of westerly waves. So we cannot ignore that. What happened in the mountains in Jammu Kashmir and Himachal Pradesh, this flood, partly to initialize the westerly waves, equally important. And the modeling community is developing models. We are also, India as a modeling community, we are contributing, IITM and many other institutes. So that is going on, and we are in a position to absorb and improve upon those models. And we are also doing the data assimilation. So luckily, the satellite data contribution is increasing tremendously. So we have seen the impact of satellite data to initialize, and even the impact in forecast is increasing. And that is continuing. And the good thing is private companies are coming in to provide even satellite data. So we are in a position to, India as a ISRO's contribution, we are in a position to design and launch our own satellite. So everything is looking good. And in HPC also, the technology as it develops, luckily government, our economy is doing good, and government is able to give good funding to our community for this improvement in weather and forecasting. So that HPC, when we have enhanced HPC, we are able to implement high resolution model, more complex data assimilation system. And now we have tested even the coupled large system data assimilation system. So I see things are moving as planned. And only thing, as many of the speakers have told, that we have to continue this good work, and we expect constant funding and support of government and now private participation. And one good thing has happened in India, I have seen in last 1 decade. As long as the model skills were not there, no private company was interested. But in last 10 years, there are maybe 100 private companies who are in India, and they want to contribute in various forms. So we have to collaborate with private companies in terms of observation, HPC, and also learn from them. And one thing I would like to tell at the end that we have put a lot of resources at MOES for creating ensemble forecasting. So though the Western countries and the developed countries are making use of the ensemble forecasting, because we know there is uncertainty in forecasting, so we have to live with it and how to communicate that uncertainty to forecasters, to the end user. So some effort is required in India, though a very high resolution. See, 12 kilometer, 2 global ensemble systems are here in India. But to make use of that, to communicate that to the end user and to our forecasters, that's a very challenging thing. We have to train the forecasters and the users that along with the forecast, how to communicate the uncertainty. Because as Professor Shukla was saying in the morning, that people will expect more and more district block and will go on offering that, yeah, we can do it, but it's not possible. So there is a limit that what the models are producing and how to communicate it to users and the forecasters. So that's also a very important area to work on. So I will conclude here by saying that things are looking good and we are in the right path, and we only pray that the funding and human resources keep coming. Thank you.
Yeah, thank you, Dr. Mitra, for highlighting the most important manpower point behind all the developments. So may I request Professor B.V. Rao, sir, please.
Thank you very much, Dr. Krishna, and all these people who have given this chance to talk. I will stress on the theory part. You see, in the case of the middle and high latitude short range prediction, probably is the best in the world, but mainly because of the Charney 1947 discovery of the Belkin instability and the ED 1949. And these two are not contradictory, they are complementary. In the sense, Charney's theory was for beta non-zero and static stability zero. On the other hand, ED's was beta zero and static stability non-zero. What I am saying is, I will stress on the theory part. There is a wonderful article by Professor Adrian Gill. He wrote, suggested that a three-pronged approach for the modern meteorological study or even other branches of geophysical science. What he said is K, U, and M. K means the knowledge, observation. U means the understanding, the theory, and we'll go for the model. So these three parts are very important. I see clearly here in the country where I worked for almost 50 years, South America, both observations are there quite a lot, a little modeling, and absolutely very much lacking in the theory part, the understanding. Please, what, for example, if you have a model, the model is the numerical solution of the Navier-Stokes equation. There are two ways of improving what was the solution, the quality of the solution. For example, you can improve the resolution from the 100 kilometers to 1 kilometer even. And the vertical level may be several levels. So by that, improving the correlation with the observation, what you are achieving is a numerical solution. What I am saying is the understanding of the Adrian Gill is more like the modeling part. Unless you understand the basic theory of the system, the success of the prediction, I doubt, will be very difficult. For example, if you see in the case of the monsoon, I suggest we should develop theory of the monsoon. I worked for a long time in South America, and what exactly is monsoon? The Binwang's global monsoon concept, probably we cannot take as the wind reversal. For example, in South America, there is no wind interruption. There are many what you call regions of monsoon, there is no wind interruption. But you can simply say probably the summer rains in the tropic or monsoons problem. What I am saying is, in the case of South America, it takes about 6 months from the onset to the complete covering of the monsoon. Whereas in the case of India, it starts about May end like that. By about July, completely it covers the country. What I am saying is, in the case of India, the Indian monsoon is about 3 months, whereas in the case of South American monsoon, it's 6 months. What controls this? What is the physics? What is the theory? Some of these things, still there are huge gaps in the understanding of the monsoon. What I am saying is, you imagine that I have a model where I have a very coarse resolution, maybe even 100 or 2 kilometers. On the other hand, I have the physics of the problem. On the other hand, I have a very fine resolution, maybe 1 or 2 kilometers without physics. Maybe the crude model with physics may give a better solution, a better prediction than the very high resolution without physics. And so, what I say is to develop theory of the monsoon. That is the idea. Thank you very much.
Thank you, sir. Thank you for your insights. And now I'm handing over the mic to Dr. Pandit Roy to conduct the beginning of the session.
Yeah, thank you, Partha. Now we'll move on to the online panelists. Those who are our guests are waiting in online. First, I'll request Professor Daniel Rosenfeld. Can you please give your comments?
Okay, if you can. Hi. Okay, can you hear me? Hello? Okay, good. So I would like to talk about the aerosol effects on the monsoon. It has been researched significantly for there is echo. The direct effect of the aerosols are well known, investigated, but I would like to focus on the microphysical effects of the aerosols on deep convective clouds, which are changing significantly the precipitation amount and the vertical distribution of latent heating, and that is an obvious impact that is presently not incorporated in the global models, not in numerical weather prediction, and not in the climate models. This was demonstrated by KIPEX experiment that was done a decade ago by IITM, showing that polluted clouds near Delhi, for example, don't have any warm rain, and all the precipitation occurs in a mixed phase, as compared to in clean situations, most of the rain occurs as warm rain, and very little goes to the mixed phase precipitation. Recent findings that after AR6 IPCC assessment show, these are satellite studies, show that polluted clouds can produce up to 3 times more precipitation than clean clouds. Obviously, there is not more precipitation overall. It is redistribution, the precipitation from the clean to the polluted area. And that if you have coarse sea spray aerosols, you have the opposite effect. So there is a very large sensitivity that is not taken into account. If you have this kind of variability, which is not taken into account, it can change the the vertical disposition of the latent heating long way away from India, but when you dispose the latent heating higher in the atmosphere because of suppressing the warm rain, you change the circulation system, which eventually might modulate the monsoon in ways that are presently not known and could affect, could explain a portion of the presently unexplained variability or prediction uncertainty. Therefore, I am proposing to test a sub-program that would test key links in the hypothesis of the that potentially explains the satellite observations by additional observational campaign, and at the same time, in parallel, develop the physics, introduce into the models the physics that is necessary. I can see how to do that without too much complicating the models and not adding too much runtime, because it is fairly fundamental reasons that or thermodynamic relationships that could be modified based on the aerosol effects, and that could be experimented in parallel. So I suggest, to summarize, I suggest to continue discussing this kind of sub-program, which could make a lot of difference. This is really, in my view, a missing physics that, when introduced, may make a substantial difference. Thank you. I cannot hear anything. I cannot hear the speaker.
We can't hear you. We can't hear you.
Sir, abhi baat.
Now we can hear.
Devi, yeah, please,
yes.
You can give your suggestions or remarks. Because we have several activities. So, thank you.
Yeah, thank you very much. I really appreciate the opportunity, and it's always a pleasure to see several of the eminent personalities, and it's nice to see Danny Rosenfeld as well talk about aerosols. So as you know, he talks about aerosols, I talk about the land, and that's what I'll be doing. But I want to start off by saying thank you to Professor Shukla for a really fascinating journey into his world that we had not really been privileged to know through the pictures and so forth. And I also go back to my graduate days when I came to IITM during the land surface process experiment in '94. And Professor Keshavamurthy was so gracious to give an opportunity for a master students like me to talk to the land surface experts at that point and share my experiments I was doing in Institute of Sciences at that point. So I really find it fascinating to see how this particular field has evolved in the manner in which now Krishnan is leading and before that Ravi was doing. And I only have three basic things that I would like to highlight that could go for the next 5 years, 5 to 7 years, if we want to focus on that. And several of the things that others have mentioned, I want to reiterate a strong support for that, starting with what Secretary Ravi has mentioned about academic resources, both about in India as well as globally as a resource. And I hope there will be a way to continue strengthen this partnership, because we are really keen on becoming a part of that ecosystem and finding a way that this could be done. Second, I also applaud the ideas about the observation. I know Rajivan was also mentioning about something equivalent to the historical climate network, and I hope we will continue on to that theme going forward. Dr. Rajivan's mentioned about portal the uncertainty and downscaling really resonate with many of the things that we want to see, making climate information both useful and usable. Into that context, I think IITM has a tremendous role to play in India to make that translation from the usefulness of the work to the usability of the work, which would involve some of the stakeholder partnerships through IMD and others that will going forward. Ravi's point about the subgrid scale processes really is a fascinating one, because that's where I would like to see much of our efforts go in with regards to urbanization. Feel both from Professor Gore about the ensembles as well as from others related to the use of AI/ML going forward. So building on these particular aspects, there are three aspects I would like to highlight. The first and foremost is the point Professor Shukla also mentioned, that land has a unique signature in the monsoon region, which can allow us to link the scales. It is a highly undervalued, I would say from the modeling perspective, commodity that we don't really exploit well. And I think with the observations, with the way the models are evolving, there is tremendous knowledge that is still lacking in the land that we can extract out within the predictability of the system. And I hope there will be some theoretical as well as some modeling efforts that will continue within IITM to that effort. Second, we have three unique features that are defining the change occurring internally within Indian climate system. The first is urbanization. Second is agricultural intensification. And the third is with regards to the role of cyclones, the landfalling cyclones and the peaks that it causes in terms of the rains. Representing these three features within the Earth system models and not just weather forecast models could be a unique contribution that comes from the IITM community. And I speak of IITM community, not just those scientists sitting at Pashan, but also the family that has been cultivated across the globe, coming together and contributing to this whole knowledge of how urbanization, how agricultural intensification and landfalling cyclones become part of the Earth system modeling framework. This could be a unique contribution. Third and last, I would say, is the role of developing digital twins. Even at University of Texas, for instance, we are developing digital twins as a part of a DOE effort, as working with the E3SM. ECMWF, as you know, has been developing Destiny, which is their digital twin. I think IITM, looking forward in the next 5 years, should embark into development of a monsoon digital twin. We have enough understanding, we have enough computational power, and we have means of doing this together that a very simplified, fast, multi-scale system can be developed for a monsoon digital twin as we embark with the next version of what has already been started with the IITM ESM. With that, I again want to thank the whole IITM family for being such an amazing knowledge source, for such a massively inspiring set of individuals. And I look forward to many such contributions, so such that hopefully over the next 20 years, we achieve so much more that we can celebrate our 75th and the 70th celebration, many, many achievements. And I congratulate everyone involved in that. And I thank you very much for this opportunity.
Pandit, you are not we cannot hear you.
Hello. Yeah, thank you, Professor Devanyogi, for your valuable remarks. Now I will invite our next panelist, Professor B.N. Goswami. Professor B.N.G.
Thank you very much. Thank you, Pandit. Thank you very much for inviting me for this brainstorming session. I was told that I would have about 2 to 3 minutes to give my comments, and I think that 2 to 3 minutes is just like a sound bite that may not that cannot make justice to this discussion of a serious subject like this, brainstorming of how we can improve the predictions of monsoon in all these scales. So I feel that, but we are living in this era of all the sound bites in TV debates and Instagram posts and so on. So probably we have to live with this. Having said that, I just came to basically, I want to thank especially for inviting me for this opportunity to come over here and listen to some of these inspiring discussions. I'll just make a couple of general points as for the theme of this brainstorming session. Indeed, going forward, the prediction of the extreme events is going to be our biggest challenge. And but focusing on the extreme events, we can realize that the extreme events are essentially the instability of the basic flow, and therefore the prediction of the extreme events, the challenge of prediction of the extreme events under global warming or warming climate is intimately related to the seasonal predictions. If the model doesn't have the mean right, then obviously the prediction of the extreme events are going to be incorrect, and therefore our focus should be improving the mean of the models to simulate the mean climate, and therefore the improvement of the seasonal forecast is intimately related to the improvement of. If we can improve the seasonal forecast, we definitely improve also the extreme events, and we'll get a handle on that. Now, but what in extreme events forecast and the seasonal forecast requires a model. Without the model, we cannot. We need a good model. In a sort of uniform modeling framework, which will be able to simulate the mean climate well, as well as the extreme events. So that means that we need to focus on the development of the models. Over the last 20 years or so, we have concentrated on the seasonal forecast, but we still have a lot of biases in the models, which restrict our ability to predict the skill of the seasonal forecast. But we seem to somehow waver our focus from this development. What I want to re-emphasize is that we need to keep our focus on improving the mean of the climate models and put enough resources, human resources as well as computational powers, to do that. We know that we have to do a lot of observations. We know those observations are required for our understanding of the processes, which then needs to be translated to improving the model. But which I am seeing that there is a lot of observation programs, and we have invested a lot, but this understanding has not gone into improving the model. Developing the improvement of the model. So I think this is where we need to focus. So this is one area that I would like to emphasize, that we keep our focus on the development of the mean model, the mean climate, and do whatever is required to do that. And then we put enough resources, human resources as technical resources that is required to do that. Having said that, the development of these models are not going to be cannot be achieved without basic research, and I think we should focus on that also. But basic research is not blue-eye basic research I am talking about, but basic research that is required to improve the model. So we have to figure out what are the biases of the models, where the biases come from, what requires to be done to improve those biases, and get and improve those physics in the models so that those biases are improved. At the same time, also there are processes, the connections of the models, the predictable drivers connecting to the monsoon system needs to be correctly generated in the model, mean model, and that also requires basic research to understand those things, and then how to include that into the model. So this is a very important, I feel, but we tend to seem to think that the development of models are slow process. So we tend to focus on certain other things which will give us low-hanging fruit. But I think if we do that, we'll never be able to achieve this challenge of being able to predict extreme events in the future. So that is why, even though it sounds like probably a broken record, but I want to re-emphasize that that development of model is key for improving in the development of better and better model is key for improving the mean, as well as which are automatically going to improving your extreme events, and all those physics are going to have to be put in to improve the mean. And once you do that, and go to high resolution, you are going to improve the extreme events. So that is my comments on specifically related to basically prediction. But even if we have a perfect model, the seasonal prediction is going to be limited to a certain extent because it will due to the complexity of the system. Because complexity, what I mean is the complexity is the event and variability or the non-linearity of most of the major phenomena in the systems, like Indian monsoon in one hand, or even system like, and so now we are beginning to realize that complexity is what is limiting our ability to do seasonal prediction, achieve our goal, the seasonal prediction. But the complexity is sort of a non-linear process. And that is, so far over the last 100 years or so, we have understood a lot about the linear part of variability of many of these systems. Like Indian monsoon, we know a lot about its mean and year-to-year variations. But still, we don't know why one monsoon is different, completely different from another monsoon, and there is no real relationship between. Similar thing happens in ENSO as a phenomenon, and people are now trying to figure out what determines this complexity. Is there a method? Is there some sort of a pattern of this nonlinearity? Can we capture that in model? So these are, I think, a lot of basic research is to be required. Is to understand this, and only if we understand, then we will be able to incorporate that into the system. So I think those are the basic comments that are short comments that I wanted to make. With that, I'll stop here. Thank you very much. Again, we are not hearing you. Pandit, we are not hearing you. Something wrong with your mic.
Could you hear me now? Thank you, Professor BNG. Next, yeah, I'm ready. So they are on Are you able to hear now? Online panelists. Oh, I think Dave is here. Okay. So next, I will invite Dr. Mahapatra, Engineer IIT, to give his remarks. Please unmute your mic.
Sorry. Namaskar. At the outset, I wish a very happy birthday to IITM, which has come up initially as an Institute of Tropical Meteorology from India Meteorological Department. And the child has grown, has become mature, and is now addressing all the requirements of the country. If we remember the expected outcome with the establishment of Institute of Tropical Meteorology, or IITM, it was aimed to augment the operational weather forecasting through research, understanding, and development of prediction tools and technologies. And that has been achieved significantly by the Institute, and therefore I congratulate each and every person at present and in the past, those who served for this purpose. So if you just look at the objective of this brainstorming session, so basically we have heard a lot from all our predecessor experts. So I will just put forth the point connecting with the basic objective, and also as an operational forecaster. Perhaps I am the only person in this brainstorming session who is representing the operational weather forecasting. So therefore, that advantage is there with me to speak what the people expect from the modeling institutes or the research institutes with respect to the operational weather forecasting. So I'll just echo some sentiments also already expressed that to begin with, the impact of climate change on the monsoon is a burning topic, and COP27 is still on. And we know that it has been aimed at the early warning for all for next 5 years. And that also IMD is trying with that with the help of all collaborating agencies, including IITM. But what we find actually with respect to specific climate change aspects, we have a lot of understanding with respect to detections. But as far as attribution is concerned, we have very limited understanding. We do not have understanding why or what is the role of GSG with respect to the shifting of the onset dates for the central India or the delay in withdrawal from northwest India. Similarly, we do not know very specifically with respect to the role of all these GSGs with respect to the intra-seasonal distributions and interannual variability of rainfall. The country as a whole being remaining almost same. The specific pockets like dipoles, someone was telling, is changing the behavior. So therefore, there is enough scope to understand, and we face these questions from media and the disaster management agencies, and also from Parliament. Coming to the seasonal scale, yes, the progress has been remarkable, and we have come up with the seasonal prediction systems in the country. But what I find that no model is the best one. And for the past 2 years, we have gone for the multi-model ensemble, and it has shown the success. The multi-model ensemble has enabled not only to provide the country as a whole forecast, but also the forecast in different parts of the country. And what I find that there is still scope, therefore, to continue the research, not based on only one model, because there are very many limitations, as it was told earlier, with respect to data, with respect to understanding of the physical processes, because this region is highly diverse with the oceans dominating, and which is the main factor for the seasonal predictions. And of course, we have got the Himalayas and many other unseen stories, which we do not know because of the lack of data. So therefore, multimodal ensembles has shown, I feel, further research can go on and we can improve further. And there is predictability for the seasonal forecast. We can go up to 0.75, which is not yet achieved. The second point comes with respect to the seamless forecasting. We should have the follow-up extended range forecast. When we go for extended range forecast, at present we have got good accuracy with respect to week 1 and week 2 sometimes. Every time we do not get good success with respect to week 2. And at the same time, the short to medium range forecast has come up with 10 days, and therefore week 1 forecast is available from the medium range forecast. So therefore, there is enough scope to address this the extended range forecast. And basically what we find that this region, the extended range variables like the MJOs and equatorial waves are more difficult to predict. So that we should understand how can we make it more predictable, and hence we can improve the extended range forecast, especially with respect to wet spells and dry spells, which are leading to floods and droughts. Next comes the short to medium range forecast, as Professor Goswami was telling, that extreme weather is the most challenging. And we have been successful to improve the extreme weather forecasting with the help of the array of numerical weather prediction models and also the ensemble prediction systems. There is almost about 79% accuracy in predicting the heavy rainfall events at the subdivisional scale in the country. But the need is that location specific and district specific heavy rainfall warning. The scale is not so high in that scale, it is around 60%. So therefore, there is enough scope to improve the extreme weather, especially the heavy rainfall I am targeting, because it is leading to many secondary hazards like landslides, mudslide, mudslip, mudsinks, and also many other impacts. So there could be many ways, as it was discussed earlier, to improve the data assimilation, to improve the observational systems, to improve the modeling techniques, etc. But at the same time, whatever we have, if we can take off some kind of heavy rainfall forecast program to assess various models, to go for systematic bias corrections, to go for multimodal ensemble or grand global ensembles, and hence we can address this issue through post-processing. Apart from the studies which are planning, Professor Ravi was telling about our research test bed coming up in Bhopal. So many things also can be taken off locally and also international, because monsoon has no boundary with the ASEAN region. The positive factors are the global factors. Therefore, perhaps the international collaboration is the key to success in this direction, where we can address the observational network and also the modeling framework required for the Southern monsoon. So another point I was just trying to highlight that in the very short range forecast, we go for nowcasting, for example, where it is very demanding. We do not have some kind of post-processed tools or techniques from the numerical models. For example, every year this region experiences intense rainfall during a few minutes or 1 hour. That is called cloudburst. And we are bombarded every time in parliaments and by the public. The whether cloudburst can be predicted, we say no. But how much or how more time will be going on telling that no, we cannot predict this type of events. So we should come up with some kind of solutions where we can predict the intense heavy rainfall events. Then with respect to monsoonal synoptic scale systems, yes, we are very good in that sense, prediction of low depressions, cyclones, etc. We have come up a long way. But when we consider the mesoscale vortex or mesoscale convective systems, still we have got challenges to predict, and we miss with respect to time scale, or sometimes we miss with respect to the spatial scales and also the intents. So there lies the scope to develop different kinds of indices. For example, extreme forecast indices. There are certain limitations with respect to past data, the computing systems, etc. But there is scope, perhaps next 5 years, we can concentrate on that so that we can go from forecast model to the hazard models. We should have the hazard models with respect to various types of hazards, especially heavy rainfall lightning I am talking of, because most of the deaths and losses are associated with heavy rainfall lightning during monsoon season. The study says that July and August is the most important month when death is occurring in India because of lightning. It's basically because farmers are exposed in these 2 months. So therefore, we have come up with lightning prediction system and monsoonal prediction system of heavy rainfall, but still there is huge scope. Our score is not so good when you go for very specific forecasting systems. So I will just conclude with this to telling that there is enough scope to improve further so that we can have hazard modeling, vulnerability and modeling, and hence the risk assessment so as to provide the impact-based forecast and risk-based warning for all types of weather events. In that case, of course, we have to go beyond meteorology also. That means we have to go for geospatial data sets. We have to go for the socioeconomic attributes. And for that purpose, collaboration that we can take up, Minister of Earth Science can take up, and we are taking off already, collaboration with state governments and also many agencies nationally and internationally. I also agree with dual engine concept. Yes, we are taking up that. The AIML and the numerical modeling should share with each other, complement with each other, and we can go for dual engine in the next 5 years. So thank you very much.
Thank you, Dr. Nopaka. Next, we'll move on to the next panelist, Annalisa G. Dr. Annalisa.
Next one.
Okay, move to next, Dr. Archana. No, it's so okay. Online panelists, can you hear me? Please, someone can confirm. I think Davis is coming. Okay, so I think then we will move to next panelist, Dr. Someshwar Dash. Dr. Dash, you can unmute.
Okay, I'm sorry. Am I audible now?
Audible.
Am I audible? Hello? You okay? My voice okay? Like there is some problem from my side on the internet, but anyway, try as much as possible to be clear. So, first of all, I'd like to congratulate IITM for its Diamond Jubilee celebration on Foundation Day. I'd like to thank the director of IITM for providing me this opportunity to be in this panel discussed. Also, of course, to Professor Tarao, who especially asked me to be present in this discussion. I'd like to thank also many people who have spoken before me, like Professor Sukla, Goswami, in fact, Professor Dev Yogi. They have made my views more easy to express. So basically, there are 3 issues I see. One is the quality of high frequency extreme events. In that regard, of course, I echo my concern Mahapatra, who says that well, on the large scale, it's easy to predict the large scale system, but not so easy to small scale high frequency events, like especially when it comes to the mountain region where the terrain is complex, where the resource is less. So it becomes very difficult to predict accurately the high frequency systems, especially when there are not thousands in the calculations, because the flows coming from the mountain side where there are very less observation, then it becomes very difficult to handle by the model. And we have seen that how recently there have been so many disastrous events like the floods in Pakistan and so on. Also, a few years ago, there was a historical tornado in Nepal, which was not predicted, and especially that was because there are not much observations in these, and so the initial conditions are very poor. Therefore, the models cannot predict such kind of events so accurately. Second issue is, of course, the usable intra-seasonal forecast. That is also another field in which we are not doing so good because short range or up to medium range of. We are able to handle the large scale system, but not really the small scale system. But on the seasonal scale, it will be difficult to handle such kind of high frequency systems. And the third most challenging issue is, of course, the skill of predictability in the change. So we don't know how the predictability will be for the changing climate scenarios. Of course, I understand that. I believe that basically, whenever there is some kind of an anomaly in the atmospheric systems, those anomalies should be possible to measure by our observing systems accurately. And if that is possible, then we can also have, and by that, having good initial condition, we can also make good forecast. But still, the skill of the predictability in the changing climate very important and very uncertain. I think that we need to continue the high resolution, also the sample prediction system at high resolution. And I read that the forecast by 2 days when we use the global model at about 10 to 12 kilometers resolution. So we need to increase the model, resolution of the model. We also need to estimate the data in the model, and especially many kind of data which is coming from new sources like lightning data. Lightning again another very challenging thing to forecast, and every year we know that many people die because of the lightning strikes which are not predictable well. So we need to improve our skill of the forecast for the lightning events. We need to increase the observations on that regard, and also has not been done at least in India is the assimilation of the lightning data. We need to really assimilate the lightning data and then try to see that how improved by that way. So and also of course hello.
Need to move on.
I'm going to wind up. Okay. So yeah, there are the things I thought to highlight, and I'm aware of two very important projects in this regard. Going on to mission, and there is of course the AsiaPax, which Professor Toru Rao is leading. We had meetings about AsiaPax in India, also at Assam, and also I think we had a very good webinar through the SAMA platform. SAMA is the South Asian Meteorological Association. So that platform also we had on AsiaPax. So I believe that these important projects like Monsoon Mission and AsiaPax will definitely provide us better skills of forecasting. Thanks for giving me the opportunity, and I stop by here.
Dr. Dash. So next I invite
Thank you.
From ISRO. Dr. Kundal.
Yeah, hello. Am I audible, sir?
Because we have several speakers.
Yeah. So at the beginning, I sincerely thank Dr. Director IITM for inviting EDISEC to this event. As you know, we have been working for the northeastern region of our country, and we know that this region is a complex region and ecologically fragile region, and is one of the most affected region by the meteorological extremes during both pre-monsoon as well as the monsoon seasons. The monsoon rainfall actually have seen over the last 2 decades has shown consistent reduction over all the 3 MET subdivisions covering any year, and this is more intensely happening over the eastern part of the any region. It is Nagaland, Manipur, Mizoram, and Tripura MET. And at the same time, the pre-monsoon rainfalls, particularly during the second half of May month. And in the current year also, we have seen that during May 10 to 20, at that time, there was heavy rainfall across any region, entire any region almost, and which led to widespread landslides. And monsoon rainfall also highly skewed towards the June month. The last part of the monsoon rainfall in Northeast region has happened in June month alone, and this caused severe and landslides. So this actually has been causing major problem in the disaster management and disaster risk reduction activities that has been taking place there. From NESAC, we have been providing space-based disaster management support for the any region, and we use the forecast that is coming from IMD and IITM. And also in NESAC, we run models for very short range forecast, basically for up to 2 days. So through our interaction with the decision makers, particularly the state and disaster management, state and district level disaster management authorities, we could understand that they need a relatively accurate forecast, particularly for the extreme events at 3 to 5 days. That is what they talk about, so that they can make better planning for the to manage the hydrometeorological disasters. So and in this respect, today a lot of things has been discussed, and we're also discussing about improving the data density. That I know the more data collection platforms. And in this area, if we see Northeast region is very, very poor. Large part of Northeast has very poor density of data. And Arunachal Pradesh, if we look, it's almost being remaining unrepresented. And we have a lot of huge international border. Therefore, we don't have any measurement across the border. Therefore, I feel that it is very important that different organizations need to join and to set up, operate, and maintain meteorological instruments, and seamlessly share the data also among the institutions for R&D. And the plans shown by Director IITM and Professor Tarutira is very promising, and we look forward to be part of these campaigns for the any region in whatever way possible. Thank you very much again.
Thank you, Dr. Kundal. Yeah. So the next year, we will get Dr. Rama Govindarajani, ICTS. Professor Rama.
Yeah, hello, can you hear me? Can you hear me? Hello.
Show them thumb.
Could I continue?
Yeah. Go ahead.
Okay. Yeah. So first of all, congratulations to IITM for 60 successful years, and here's wishing it bigger successes in years to come. Now, I haven't been able to hear clearly everything that was going on, so I'm very sorry if I'm going to be repeating something that was said. A lot of important things have already been said, and I've greatly enjoyed this session. I want to make the case for greater interactions between theoreticians, performers of simulations at the smaller scale who look for microphysics, and with modelers. So I feel that in the monsoon problem, we need large interactions between all these different groups of people. And as someone who works on cloud microphysics, in particular, I would like to emphasize for better connections between people who do direct numerical simulations, large eddy simulations, and all the way to large-scale models like the model of Dr. Krishnan and his group. It would be very nice to have, direct connectivity between small-scale microphysics simulations and the big models. So given that monsoon clouds are so different, it would be important to do direct numerical simulations with these parameters in mind. So for one thing, like we have done a small study in 2 dimensions where we showed how cloud turbulence due to its thermodynamics is different from normal turbulence. So if you look for any Kolmogorov or standard scalings, those become different in cloud turbulence. So this thing we're already trying to explore in collaboration with IITM with the group of Dr. Bipin Kumar. And in terms of the monsoon, I'd like to make the case for theoretical, simpler descriptions, like statistical descriptions, which take the monsoon down to its minimal description. And this is going to be important in the context of climate change. Of course, you know, short-term predictions at the local level and at the very accurate predictions for different localities. Those things are very important, but I'm going to the completely other extreme of, you know, coarsening it to the largest scale in time and space and getting responses to climate change. For example, in the mean and higher order moments, this should also give information about extreme events. That's all I wanted to say. Thanks for your attention.
Next, I'll invite see now Dr. Shrestha. Dr. Archana Shrestha. I hope online panelists are.
Thank you for IITM for inviting me and Dr. Toru for motivating me to be participating, at least not physically but online. Thank you so much. And I would like to say congratulations and happy birthday to IITM. I would like to share one slide. Just to make. So when we talk about monsoon, it has a special variability over South Asia. If we are talking about South Asia and Southeast Asia, monsoon is totally different from what we see in South Asia. So in this regard, even in over the Himalayas, it's different than what we see in further south. So I would like to have 2 basic points on the monsoon, understanding monsoon and forecasting monsoon. If we are talking about forecasting, mostly we are focusing on rainfall, I guess. But the dynamics plays a role. So in the context of changing climate, I think we really need to look at the synoptic scale system changes. Generally, when we think about monsoon over the we miss upper year part analysis in the upper year, and especially we think about easterlies, mostly over easterlies. But we have I think there are many research papers that have shown the interaction between monsoon and the upper level westerlies has a connection with the heavy rainfall. So, and there is a number of papers which says the changes in jet stream and westerlies with the changing climate and with the warm climate. So we really need to look into how the upper level effects. So understanding the process and life cycle of those storms, and identification of various signals criteria for forecasting monsoon, like like deep trough or upper level potential vorticity anomalies that would interact with the low level mountains there. So I would suggest that. And in this regard, I think one of the reason why the synoptic scale there is a gap in the models is upper level measurement in the upper level. So in Nepal, we have one radiosonde only for last few years, and we in Kathmandu and do only one measurement. I think if we can use the satellite data to verify the various sounding, then I think we should incorporate that in, which can be used for data assimilation or model calibration as well. And just recently in IPCC, the scope 27, it was announced that the Nepal is also listed in SOFT program, which is Systematic Observation Facility, Finance Facility. So basically, it will focus on surface and upper level measurements. Definitely, we are hoping that we will have more upper level measurements. So with this, I think we can better incorporate the upper level data in the models, global models, as well as the regional models. So that this is one of the reason. And we can do a number of experiments for the model improvement on extratropical and tropical interaction. Generally, especially in the northern part of South Asia, where the mountains are there, and also the better representation on the role of the elevated mountains, which goes all the way up to above 5 kilometers. So I think this is one aspect that I would like to share, and I stress this because there is a paper on quasi resonant effects, so which already shows the changes in jet stream. So I think this is very important. The floods in Pakistan, in Uttarakhand, even in Western Nepal, is associated with.
Thank you.
And finally, on the mesoscale convective system, the changes in the mesoscale convective systems, which is more of generation of the monsoon itself. So I think we need to do some data assimilation with the radar data. Nepal is going to have 3 radars by May 2023. So we are hoping to have better data assimilation on the model calibration, and need to look into what is the life cycle and process of these systems, and what are the changes. Thank you. And thank you for letting me having my words.
Thank you all the online panelists. We have many speakers lined up here. We have only 2 minutes left. I'll invite Yoshi, the former IIT scientist. So, yeah, please. At the same time, shall we give you one? Oh, yeah.
Again.
I was not expecting that. But it's a gathering. Something about what has been going on is extremely important. I've been listening to analysts coming from the of observation, that is space. I would one of the small suggestions that make efforts if they are selected, like the percentage of the now in modeling, many things are still remaining. The standard processes, they have been trying hard certain land or some small scale experiment. But what they need is bigger experiment in the space. And anytime on the space of the is that they have 1 or 2 satellites with 1 cloud experiment, aerosol experiment. There is nothing continuous data. I suggest after examining many of these interactions, but I think are quite the small scale predictor, try to single out one observation and put that forward to the space community, and we should have a longer time generation to ascertain that certain things about it. Now, what are the things in there? This is easy to say something like some of the things highlighted error. Now, we do have the information from somewhere, but there are sporadic variants, complete systematic, not all the characteristics, whatever the information we require about the satellite.
Now there are potentials available, there are teams available, and as said earlier, now the time of the biggest satellite gradually goes, but there are small scopes. So my suggestion, small suggestion on the IIT portion day would be one of the suggestions to come from the IITM, including all the that we should have it could be need not say the gigantic satellite, getting over. Small satellite, but consistent for the longer time so that the data will fit in the model and that the small suggestion. Thank you very much.
Thank you, Dr. Dipsi. I'll invite Professor Raghu Muthugude. Yeah, maybe to save time.
There is not much more to be done. No, I think one thing that is missing in my mind is ocean's role. Indian Ocean is very unique. Getting heating from the Southern Ocean very quickly. 10 years, the Indian Sea is forming, and I think the Arabian Sea is now playing a disproportionately large scale in terms of the shift in the low pressure system, shift in the low level jet. So the flooding in northwestern and Pakistan are all related to these ships. So there, Bengal is not warmed because already at the threshold, and any warming will just release the energy. The Arabian Sea is one very unique things, and it's very closely related to the fact that Middle East is warming very uniquely, and these are starting in the pre-monsoon season itself. So these things I mentioned overall, especially because this is about if the monsoon changing climate, and that part of as much as so I think that. Thank you.
Thank you, Professor Raghu. So next, Dr. Terry Foster.
So thank you. Yes, many things have been said about that. So I will take a strong point of view, some kind of point of view, bridge the gap between the different problems. First, for me, it's little surprising to see that some people are still saying that statistical prediction must be done of dynamical flight. So, in some sense, it can be interpreted as either dynamical form. So, why is that? Just to right to the point, I think in IITM, lots of people dealing with climate model, which are very expert in that. So, I would things, monsoon, obviously, and you people who do observation quite nice. For example, the day before, very nice writing what is doing with wind, and you are running model very efficient. But I think you don't have enough to know exactly what is inside. So really, if you want to reach the gaps, all about doing the observation, go on the side, and go on the people who are expert in climate variability, which is you need finally for a user. In fact, you need much more people who know exactly what are inside the both for the ocean and the atmosphere. And so, for that, you need time, people, and you need to perhaps revive the way you see consider the career of the people. I mean, if you just choose people of the number of people that achieve, then nobody will be staff question because it will be against this promotion. So, in some sense, you have to have a dedicated to know how to be on the human side the gaps in observation, models, and interpretation of the simulation. So I think this is the key point because, for example, I remember that there are a lot of options from observation. In the Bay of Bengal, there are a lot of ships. So the dream was some unity scheme parameterization in the ocean. I'm not sure that's for example, and probably because you miss experts different questions. And for this, we need time, I guess. And we just conclude. I remember some discussion we had in Chaos before the launch of the issue. He said that he was in fact against the way the solution was done first. He was saying the best to have any technical model is to put some people in some remote place together and to live there for 2 years to build a model, and then perhaps you have a good engine model. So maybe it's time to do that with the model you have in hand, to spend some time to see, and so to improve the documentation of the model, so that young people who are trying to use this new model, they will not waste months or years to know how to use the model. And
Thank you, Dr. Terry. So next one, Dr. Anand.
thanks to the ARCO observation program, we are in a much better position at this heat stored in upper layer position. I tend to believe that we need to examine the heat storage in the upper layers on the seasonal. Maybe we should take a detailed analysis and put it in the class. Thank you very much.
Thank you, Dr. Anand. So next, Dr. Anand. Dr. Anand.
Makran.
Thank you. I don't have questions. Some recent research has shown that there are some characters that the history of the proposal to not so high. But I'm not one of the investigators that's federal. And there's something called the equivalent potential. So which it's a kind of noise that is so in addition to this agent, this the potential agent also important. So both together provide a better of they has much more influence on weather and precipitation and events. And so we should have time series measurements of time. So that because that has great bearing on the stream with that events.
Thank you. Thank you, Dr. Anand. So next, I invite Dr. Ajit. Dr. Ajit.
I can reflect IITM for the last 60 years, and I offer the coming years the way for place for the modeling. In fact, I was wondering about the statement that some of the models we are getting on our mobile ECMW models. If you could first some graph to customize and validate how good that global model is downscale to the regional scale is giving more information for the regional scale model. So maybe that's a good step in parallel and complete with the work model exercise is what we are doing.
Thank you. Thank you. So next, Dr. Ramesh Kumar. Dr. Ramesh Kumar.
I would like to stress that we need more observations over the ocean, as Raghu and RRR said. We had actually several experiments starting from Monax, Mansoor, Amex, and Comex, etc. But we need to have actually more observations over the ocean. Thank you.
Thank you. Yeah, next I will invite Professor Chandrasekhar, IAST.
Yeah. So
So I mostly work with weather, but this is a climate seasonal thing. But anyhow, I'll just use. I know it's a very difficult, very hard problem. Our colleague earlier mentioned we need to identify a set of very dedicated people. Let them spend 2-3 years separately and work on it. So that is a very ideal solution. I don't know how practical it is. That would be the best sort of solution, I would presume. But looking at the practical thing, how to go about this, like for example, I also agree with Professor B. N. Goswami. He said ultimately that we should be able to simulate mean climate. If we take care of the mean climate, then possibly the extremes will automatically be taken care of. However, so what I feel is say that IITM, as I understand, has developed a Earth system science model. So now the thing is, so this is the best model for it. Now, if it is so, then let us take this model and investigate how well we can simulate, let's say, the floods over this farm which happened this year. Now the question is, there would be several aspects or different processes in the model which would actually, firstly is you have different simulations, different possibilities exist. Model does reasonably well, model does very badly. If that is the case, first we have to find out how good is this vis-a-vis, let's say, the Pakistan. Then in that case, then we will have to sort of break it out. Now there could be effect of land use, there could be effect of weather zones, there could be effect of oceans, there could be effect of like subgrid scale parameterizations. So then what we should do is we should know all these things cannot by a single institute. According as the Secretary has also indicated that there should be interactions within the country as well as outside. What has to be done? Let's say land use. The people who are working that have to be identified within and outside, and then these people have to be asked to test whatever the various schemes that are possible right now, and then find out which is the best. So similarly, other things will have to be looked at. What is the best cumulative parameterization scheme available? The best microphysics? What's the best radiation? What's the best bound layer scheme available? So all these things have to be done by different groups. And then once you find which is the parameterization is to reasonably simulate, I won't say the best, then we will at least know where we stand. So then we should consistently see how which can be improved. How improving different parameterization schemes are going to take different sort of efforts, different sort of, what I should say, difficulty levels. So we should like to look at which has to be taken up on the we should like to have the best impact in terms of the improved scenario. I think this has to be done systematically, and it requires more than an institute to really do it. And ultimately, finally, I agree that we should have a model. We should be a new model. We should actually have the best what we have today. Now, it may so happen that some of the schemes that are available today do really reasonably well. Right? And for example, even if you have a new model, a new parameter scheme, let's say the land surface parameterization in the new model that you've developed is not as good as one of the existing land surface parameterization. So we have to take what is available best today and then try to find out which is the existing model, which is the best parameter scheme which will work, which is the best. So once we know that, then we have to go on improve one by one how we can improve. This is a very long-term effort, and we have to be clear what we have to achieve and how we have to achieve. I think this is very important. It's not something that you look a magic wand and you get a solution. Thank you.
Thank you, Professor Chandrasekhar. Now I invite Olivier. Would you?
Thank you very much for to speak. Congratulations to IITM. Obviously, I would not as an expert. I want to know what I am now, but I wanted just to tell 2 or 3 things about. It's interesting. Years ago, when I was speaking with students of young people about the view that planet is over, that everything is catastrophic when you see the social network about the news. I was always giving an example that everything is so hopeful on that. And I was giving the community, the world community of scientists working about climate as a thousands of people working together all over the world during tens of years together. It just show the very nice and beautiful side of money. Second, at the same time, I was seeing also that these activities, since I heard about it in the 90s when Professor Akademi, I saw the evolution every increasing and widening the spectrum of specialties because you just spoke about that equation that we for modeling the atmosphere, and then I remember that people were saying, oh, but we need to include ocean, cooling ocean. Oh, we need to see ice. And if I'm not wrong, today we incorporate biology, or in the ocean, but also for today the community of people, scientists working or touching with the topic of climate. You have people working for microbial biology, or obviously you heard about light and space techniques and the usual mechanic climate modeling, etc. Community biology, but you have also socioeconomic problem about coastal management and so on. So the topics it's really wide today, and so two key points for me about that, it's the interdisciplinarity and internationalization. Internationalization is a bit of my work today. And the second point is about what Dr. Abisoman thought. I was very sensitive, and I know that people also thought about how to enforce the human resources for all the experts of Pascal also talked about the need that we more experts working together in the field. So, and speaking about the way of getting closer to research institution and academia, when I'm very sensitive to that. And I'm a very modest example that we have in France, as a researcher, or Pascal also, that we have the system. I don't know if it may exist in India, but it's the concept of joint research unit. When you make research center where you have both faculty and researchers. And my experience is that it's absolutely wonderful in academic where people teaching and spend only half time for research. They don't have so much time as a researcher. So when in a team is coming one have people who intensively working full time for research, I don't know how to say that, but it's increasing absolutely drastically the energy and the dynamism of all the team. There are people that thrive along the progress of research. And also for research, he has more people to interact with. And to my point, it's a very difficult. Thank you very much.
Thank you, Dr. Williams. Next, I invite Dr. Rajkumar.
I don't know really what to say, but I think a couple of data become more rigorous. The ocean is more rigorous. So already I something on the two couple of months the global world is seeing the office are currently doing much better than the forecast. So I think we also have to migrate that. That's again subjective. We see. I hope this model should be provided this model. And on the monsoon, importance of monsoon, I'd like to say that I was in charge of the International Monsoon Storage Office here. WCRT is working on monsoon activities. So there's a open science conference in 2023, October, in which we as managed to get a special session on global and regional monsoons. And I think we have people like Surya who's co-convener in that. We hope that we attended ideas.
Thank you. Dr. Gopal. Thank you. Just like make up suggestions, and we are looking into the short and related basis. There have been days that three reports for day one class is not robot. We'll have to take something and book and why the job. There is one point of first also, and need to certain why it is. They come out with something, but I know setting reading some more understanding the underlying. Thank you. Thank you, Dr. So, Dr. Sahai.
Thank you. Changing climate. So we have to first talk about climate and how to address global warming, and then we have to go for monsoon forecasting. So our Prime Minister has already put some light, which is actually to promote our Indian culture in the life. Earlier we were focusing on reduce, recycling. So we shall like on that we have to inculcate that again, tell other people in the world to follow that, so that global warming can be arrested. And the second, which is already through the models, we see that IITM, we do have seen for storage, using radar, experiments, parameterization of clouds and things, and also the experiments are being done to that. So already we are doing an improved model, but I will focus on more on sales, so that already Patra and Raj also told how to compete. We are not able to get properly whatever the class we do, generating the skills, and and particularly giving say that the forecast is not of this, and if we are giving district forecast for stories, previous, how that used by farmers and other. We also don't say that percent normal and 30% abnormal, how the people will use. So this training. Thank you.
Thank you, Dr. Sahai. I saw a hand raised from Dr. Somnath Datta. So after that, I invite volunteers, colleagues, so who have students.
Thank you for the opportunity. Actually, during Dr. Krishnan sir's presentation, he was saying that throughout the monsoon season this time, monsoon trap was south of its mountain and we know actually during our elementary trainings we have heard that monsoon trap is a region of barotropic instability, and at the eastern end of the monsoon trap, all the monsoon flows, small vortices form. So the monsoon trap at the very beginning, it was very south of its basin. We had many lows over Bay of Bengal. But as usual, as we have learned during our elementary training, monsoon lows moves along the monsoon track, but very much south of this basin, as a result of which Bihar and West Bengal, all these things, they are divided from them. Thank you.
Thank you, Dr. Datta. I invite now Surya.
Yeah, thank you for the opportunity. So one thing has been posed as climate reactions. Situation is not that bad. Actually, things are better. As Sasa said, it used to be very bad, so much better. So what is the point that what everybody was telling very clearly, making a clear statement that any state has to be. So which means state? That is the question. Is forget interest that. So when it comes to the research around forecast, what we noticed is that most of these climate as the tri-bias So why is that bias? So we have addressed the system. Then we noticed that LPS, which are the major rain bearing systems from the Bay of Bengal, they are propagating into the land. So if one of the major outcomes, scientific outcomes that came from monsoon vision, scientific outcome, I'm saying the improvement of scale, is that we have noticed that synoptic variable is underestimated of climate models. So that is where we have been very important to get that correct. For example, LPS, why they are just forming over Bay of Bengal and not penetrating into the deep landmass. So what we did, we tried to address that by getting diagonal correctly. Place the amplitude cycle of SST and distribution in the models is very much under. We all know that. So that is one of the reasons why the extremes also are not getting proper in the models. So when we tried to improve that, so we started getting this red bias distribution almost 50%. And I want to tell to Shikasa, see, you have shown that 128 scale for the same period, same model, then you are able to do the diagonal cycle. The skill has doubled almost. Yes, and the tab is already published and I can share that. So the synaptic variability is the key. As everybody mentioned, mean state, in the mean state, in the synaptic variability, diagonal variability, correctly, may some better prediction skill, doing the skills. That is what is my suggestions to this.
Thank you, Surya.
So one of the major problems all the climate models have is its teleconnections in the node is more than the axis. Because of the teleconnections, the other modes of variability are underestimated. I think this should be one of the priority areas we should focus. The another one, in line with that, we have many suggestions to improve the model. But in line with those efforts, we should also see whether the models are able to get you some dynamical features which can, in effect, give us some idea about improving the. For example, the substitution features in the models are improving a lot compared to what we are looking at the rainfall over the Indian landmass. So whether the circulation features can be used as some sort of predictors, or whether we can improve the monsoon forecast using such information, maybe using AI or any other, with the help of AI techniques. So that also should be taken into account in line with the model improvement, because the model improvement is a long time effort. But at the same time, we should also see whether we can improve our forecasting, which will be more useful to the public.
Thank you, Dr. Seelan. So I invite some next scientist students, their suggestions, PhD students, and researchers. Meanwhile, I think Professor Shukla had 2 minutes to share his views. So whether we can decide who wants to ask some questions. Shukla.
Actually, my comment is just so many people said one thing again and again and again that we need to build capacity, we need to have cooperation, we need to have interaction. This and this is something that in IIT use every recommendation year after year. So everybody knows this, that this is to be done. And everybody says that. It's almost like so why it hasn't been done? So the reason I wanted to make a comment that it's the first time I heard someone in the position of secretary of FOS put that in their remark. Then I examined it because simply first of all, to support, but not just say it, but to just make a suggestion how to do it. You go all over here in any of the research institutions that are doing, so that's, I'm concentrating on modeling, right? They have no idea about what CMR model is or what IITM is. They're using on their laptops something from Trieste or something from somewhere there. How to get, so here we're trying to build capacity, how to use the capacity, and by the way, Dave Yogi did it also in his presentation, how to get people involved. So there are many ways to get involved. Money is very easy way. You get the money, but you give money for what? So here is a very concrete suggestion. You should make sure, sort of somehow, guys, sure, that sounds authoritative, but the modeling groups, the big ones, and by the way, first of all, why do we have 3 modeling groups? Modelers, that's a separate question. I don't want to go with history and politics. I don't want to go there. But wherever it should be certainly the discussion should be had. I think that universities have told me many times they cannot have access to the computer at the IIT, at the NCM. They don't. Year after year, so I will suggest that there should be a definite plan to seek out. There are not many which have the sort of the critical mass to be able to usefully involved also. After university also, but make a plan and at least make a start that the research community, research in a group somewhere, is actually directly involved with the modeling, not just by money, plus connection. They have allotment of time, so then they can experiment with it. And these modeling groups have to know that this part of their responsibility build this capacity. But in the beginning, they may think it's a waste of time. But give me, in the long run, they will have the benefit. Then you will have a whole bunch of information. So just wanted to make this comment because it's just so many years hearing about it. So many, and look, you go to the ANPA. Do you know 200 universities have an account there? They run them all, and there's also some investment. It requires support. You cannot just say to IITM, so that okay, give it to me. They'll show up busy. First reaction is, oh, our computer is busy. There's no time. No. If this is the policy, if this is the part of the national development of the capacity, something like that has to be done. And it will be hard and big, but get it started. And you will create a network where you will have university scientists directly involved with the model. Thank you.
Thank you, Professor Shukla.
Yeah, sir, we have almost all universities that are involved in weather and climate modeling, and we have. Yeah. So more than users are using computer as of today from outside of universities. So that we cannot. There are some papers, for example, the irrigation, Chandrasekhar, and back me up. Actually, architecture with some papers. Yeah.
I think we're done. Okay. I see some hands raised. Dr. Tara.
Thank you for this opportunity. Actually, I wanted to say something about the how do we know warming environment? How the clouds are going to behave? Are they going to be deeper? Are they going to dissipate? Are they going to be having the kind of organization, structure, etc.? we need to understand, we need to make a hypothesis. What is going to happen to the Indian monsoon clouds, especially, and what actually based on that we have to frame our questions and try to answer them, try to make field camping observation. What are the observations we need? What are the intricacies of the model? How are we? See, it is not only the clouds, not only the heating. They also cool the boundary, cool the. There will also be a cooling that is happening. So, what is the impact of conflict, and how do the convection and organizes? There are plenty of questions to be looked at. Actually, in the physical point of view, we are not really addressing these questions. We have insufficient observation. I must say that whatever efforts we have done is very, very minor, and we need to improve upon. And we not only the field captains, we have to have limited observations with aircraft, radar, etc. And the point is, it gives very insightful insights that can lead a better development. How we will contribute is that we can develop golden case studies. We can have intercombined projects, and this has to be part of our blood. And there is no point. We are not going to make any kind of improvement unless and until we understand the physical process. Actually, I have been speaking with Dr. Krishnan. He has been saying, and he telling me that we need to understand the problem. How do we understand? We have to look. We have to have observations as well as models and modeling it. And at this point, I have to say is that we have to have a number of trainings and workshops, and this is inadequate. And also, I have not a few points for because I'm not right now. I'm getting it. But I have a suggestions that I have put it down, and it is really privilege. It is I must say that like October 60 years, we have a long way to go, and we have to recognize our end. And they to be like one thing I also want to mention about the lab strength. Actually, lab strengths are very important because we know very less about interface cloud application properties, etc. We know, see, some of the models we can get observations, we compare with, we can see that the developers of cloud signals, we will see very good comparison. When things start, it drops off. Okay? So it is very, very crucial that we understand the process from the brain starting of the spell. So actually, so many things. Sorry.
Okay. Yeah, thank you, Dr. Kara. I think now I think all are hungry and have to.
There's one question, I think, about
Okay, quickly take that question, and this is the last question.
Thank you. Thank you. I have very question to provide. So, as a partner in some prediction or seasonal prediction, I wanted to know you. You see that seasonal prediction scheme where the scheme all Indians, and if you go for each one still it's good. So, say Guru as a pioneer, I ask you, what is the limit? The limit you aim for all India most skill or and as well as midpoint skill? Simple question. What we should aim for? Or what is the limit you look at?
Well, just to estimate, I mean, that's a little bit of a theoretical exercise. You can do. There are many things potentials. I know who and wrote some paper, but how could now actually there is a new paper. It calls it predictability paradox. So in other words, depending upon one way of predictability, you say this is it. The actual focus is better than that. The reason is that simply because the amplitude of the participation that you're trying to predict is so low that your classical way of calculating probability by looking at dynamics, it just doesn't work. But so far as the monsoon is concerned, really question, you don't need to theory. I mean, I've heard a lot about theoretical work. Yes, our whole field grows by this marriage, which is observation, theory, and model. And by the way, we call Charlie guy. He's the one who always must have that. One big the other. I think if you look at the errors, are just so sort of close, so different, that and you know that this is because of having a problem with capturing the synaptic states. That's something already mentioned. I think Surya said. We know that because of the change in the state. Right? Whether somebody sent a question, how can we put main state? Why we don't main state? And again, it's not a question. I'm not going to answer that one sentence. Somebody said that put 3 people away and they will improve. Sorry, that's not going to happen. I think, but the point that you made was very good that so long as reward system based on how we prescribe and so we're funding. There is no mountain group in the world which goal is to improve mean state, the mean climate. The mean climate gets improved because we are stuck with some problems. All the global analysis, why they improve mean state? Because they find that there's no energy balance not satisfied. The amount of energy under imbalance for the global warming. So they went ahead and fixed it. So in the case of monsoon prediction, I'll say that the most important thing to do is get the statistics of the synaptic states right. Okay? The statistics of the synaptic states are number one, but the impact of the forcings like the La Nina, equinoctial dipole, any of this itself we're not getting. So I ran through it. I had three slides on this question, and I ran through. So we need both challenges to be able to do. We get the synaptic and get, and by the way, we are improving. We're just, and I didn't want to give the person that we're not making progress. We're very huge progress. But if you look at what has happened about 20 years ago and now, we made a big progress in just understanding the system is predictable. And we started. After that, we're not able to do anything more than what a big lean getting report. So I think the question of signal to noise, the standard evidence are, we don't have a area, that you come with the question and your skill heading to the limit. Now, if you are asked correctly, have we reached the limit already? Yes. That can be a way of posing your question. And I can assure you that that's not the case. And that will be a much longer answer. See, right now, if you look at the, we do I gave 0.9, but that 0.9 is a number based on 30 years. And I'm glad that I'm not aware. But you said that there's another model for which this 0.49. That's a very good number. By the way, they still have all the statistics is zero. So therefore, it's a very good number. Yeah, to that for. So there is a lot, and look at the individual events with the we're all halfway there. They will predict the system, not the remote response, but events. So I think that ask the question, what is the limit? Is an academic question. We should be faced with this question when we have removed our very obvious problem right now. Yeah. Because I can give you the method calculating predictability, which will say predictability limit is very high. I can give you another method which will say predictability limit is low. I mean, you guys just you see that. So that's, I'm not avoiding the question. I'm saying that we have absolutely not reached the limit. There's a lot of to be realized. The whole panel can make a seasonal predictor. That's the concluding sentence. There is still unrealized thing, and we have, and we don't talk about the precise definition, which is a statement made many, and many ways. Okay. Sorry, very long answer.
Thank you. I think with this 2 minutes.
Yeah,
Yeah, with this, we can conclude this brainstorming discussion by thanking all the expertise and analysts and those who joined the online and different time zones. We want to thank, on behalf of IITM, to thank all the panelists and expertise to IITM to joining this brainstorming session. And so sorry that we delayed your lunch. So lunch is arranged in Punang and the basement. So we'll again join at 3 o'clock. Thank you. Thank you.